Good morning. It's wonderful to see so many people here in Senegal, and we are delighted to welcome you to the Deep Learning Indaba 2024. So, where AI is happening, an enormous amount of work has gotten us to this point. And I don't just mean getting to Senegal, which I'm sure has been pretty arduous for many of us. I mean the work that everybody that has put into the AI ecosystem over the years. And the Deep Learning Indaba started in 2017, and we're here now in 2014. There are 47 countries on the African continent represented here at the Indaba. Within that, there are 47 Indaba X communities in each of these countries happening every year. So it's an enormous feat. And it's just an example of how the Deep Learning Indaba continues to push the boundary of what inclusivity means. There's greater representation across the continent, as well as the female participants. And thanks to all of our sponsors for allowing us to actually send a lot of people here, 200 travel grantees who are able to make it every year, thanks to the sponsorships. So what makes the African AI research ecosystem so unique? And for us, it's the spirit in which we gather. So the values which are embedded in how the African AI ecosystem does its work. And I think it allows us to ask the questions that what happens when Africans own, contribute, and shape the AI, and what types of systems are built, and which problems are then addressed. And this is the spirit in which we gather here for the Deep Learning Indaba. So a little journey from 2017 back in Johannesburg, the first ever Indaba. Next slide, please. To 2018 in Stellenbosch. To 2019 in East Africa in Kenya. Next slide, please. And then, of course, we had a little break in between, and we came back in 2022 in Tunisia, into North Africa. And we are delighted also to reach Ghana in 2023, and finally, we're here in Dakar, Senegal in 2024. I'd like to now pass over to Dauda Tanjim-Jiba, who will present on and welcome everybody to Dakar.
Thank you. Thank you, Emily, for the introduction. So, first of all, welcome. Welcome to Senegal. I think it's important to the country to host this Deep Learning Indaba event. And it's really important for us. So when it comes about AI in Senegal, as the landscape of AI evolves globally, and proximity to the state-of-art facilities such as the supercomputer data centers, the PTN, and also the MESRI, and also the commitment of the University Amadou Mahtar Mbow. So Senegal has a vibrant AI ecosystem. So recognized on the international scene through the Galsen AI community, which has been working to popularize artificial intelligence in Senegal since 2018 with Indaba X events and other activities. We also have the Women in Machine Learning and Data Science community in Senegal, l'Institut des Algorithmes du Sénégal, and also ASIA, Association Sénégalaise pour l'Intelligence Artificielle. So we have those communities, right? But also we have the Hub, AI Hub Senegal, which is a new initiative that aims to federate all AI local players. And it's really important for this ecosystem to have a central piece that can coordinate all those other communities or activities that we want to develop in Senegal. We have our invited guests. We have the rector of the university. He's the chairman. I think that we can introduce him after because he's not yet right now. We have the representative also of the France Embassy, Mr. Florian Blasi, and the representative of the Ministry of Telecommunication and Digital, and the Ministry of Higher Education, Research and Innovation. Yeah. We can start by welcoming the one that is present, or we can just follow up with Elizabeth and then come back to the presentation afterwards. Yeah, okay, I think that's perfect. So let's move to Elizabeth. Thank you. Sorry, just one thing to add. The theme of this year is Ham Hamle. Ham Hamle is a Wolof word that means gain knowledge and share it. And I think it's the idea of the Indaba. So the goal of the Indaba is to strengthen the AI community and also the data science community across the continent of Africa. Thank you.
Thank you. So my name is Elizabeth. So I'll be presenting the Indaba Week. You scroll the slides for me. So I'm going to present some of the activities and engagements that we have for the entire week. We have some demos, mock interviews, panels, socials, mentorships, workshops, prizes, awards, posters, practicals, ideathon, parties ongoing, culture activities, tutorials, keynotes, hackathons, oral presentations. And on daily basis, we are sending emails to you on these activities plus the program on each day, so you can check on your emails. So make sure you catch Women in Machine Learning panel that will be taking place tomorrow at 7:30 p.m. And this is open to all attendees. And then we have a community session taking place tomorrow again from 4 to 6 p.m. And this again is open to all attendees. So still on some catch-ups, we have a poster session on Wednesday from 10 to 4 p.m. And again, a poster session on Thursday from 10:30 to 12:30 p.m. We also have awards presentations that are taking place tomorrow, 8 to 9 a.m. Awards presentations on Wednesday, 8 to 8:30 a.m. Thursday, still awards, 8 to 8:30 a.m. And then Saturday, 2 to 2:30 p.m. So again, still on the catch-ups, we have a culture day and a dinner on Thursday, 6:30 p.m. To 9 p.m. I expected to hear yeah, that's what I expected to hear. Yeah, there's a culture day and a dinner on Thursday, 6:30 to 9 p.m. And then the dinner is available for attendees, and then we will have some live performances on that dinner. Then we have ideathon presentations. Oh yeah, you can clap if you feel like doing that. Nice. Okay, thank you. Thank you. So we have ideathon presentations on Wednesday. This takes place at 5:30 to 6:30 p.m. And then we'd like you to come and hear more on the program and this year's edition. Again, you will learn about some of the last year's projects on that specific day and time. So again, on Ideathon for this year's, we have a Slack channel, and we'd like you to get connected with other participants through that channel. And then we have a networking session tomorrow at lunchtime at Annex 2. And then Ideathon presentation on Wednesday at 5:30 p.m. That will include details of the program and then also showcasing some of the last year's projects. We have a mentorship session on Thursday at 4:30 p.m. Most of the competition will take place after the Indaba. So you can get, as you can see, the people engage with that. We have their Twitter handles presented here, so you can get connected to them. So all ideas are welcome on the Ideathon. And then we have amazing lineup of prizes. It includes grants, compute, mentorship from researchers and experts, courses, and many more in the line. At this particular point of time, I'd like to thank our sponsors who have made the Ideathon possible and also provided these prizes, making them available. At this point of time, I'd like to welcome Emily to take you through the code of conduct. Thank you.
Super. Thank you so much. So I just would like to remind everybody, I'm sure you've seen our code of conduct in our emails as well as in our welcome book, and it's just really, really important to us. Our philosophy of the Indaba is family and unity and sharing, and we really, really require that you respect these principles. So please, if we really would prefer like no incidents to happen, but in the case that anything does arise, we really want you to reach out to us, okay, and feel comfortable to reach out to us. So everybody that's wearing a red t-shirt, red lanyard, if there's anything that's concerning, you can reach out to us and we can, manage it from there. Thank you so much. Emergency contacts, you also have this all in your welcome book. So police, emergencies, we also have a number for the accommodation as well as for the safety committee. And we're going to have a booth in the booth area, which I believe is this way. And it's just this way, just in front of the registration desk. So go inside and you'll see the Deep Learning Indaba booth. There'll be some of us there at different times. And if you have any questions or queries, you can also just come and reach us there. So we'd like to recognize our incredible partners for the Deep Learning Indaba, which includes the university. Thank you so much for allowing us to host this event at your wonderful location. Just going to change mics. AI Hub Senegal, who has been an enormous facilitator of this event. It wouldn't have been possible without AI Hub Senegal, so thank you so much. Our Mawenzi sponsors, please, big round of applause for our highest tier sponsors. Thank you so much for supporting the Indaba consistently. Our Nile tier sponsors, keep the round of applause coming. Let's go. Nile tier sponsors, our Congo tier sponsors, thank you so much. Our Zambezi sponsors, our Limpopo sponsors, and one more round. Let's go. Keep going. Our Senegal sponsors, and one more round. And finally, our Saloum sponsors. Thank you all so much for supporting the Deep Learning Indaba. We have representatives from so many of these organizations that are here. You'll find them in the booths again. You'll find them on the ground. I'm going to pull them out. They'll be wearing purple lanyards, so you can talk to them. Our affiliated communities, we have an enormous amount of communities that are also present. We have a community booth, again, happening in the booth area, so you can reach out. And Elizabeth already told you about the community session happening tomorrow, so you can also get to hear from the communities themselves. So we'd also like to give many, many thanks to the incredible organizing committee who have been working on this event since last October. So thank you so much to each of our teams, local organizing, sponsorships, applications and selections, publications. Can I get a round of applause, please? Program committee, travel, community, faculty, accessibility, safety and inclusion, communications. Keep it going, Indaba X, Baobab, mentorship, Ideathon. It wouldn't have been possible without the 80 volunteers that actually managed to make this event happen. So as you know, we have our Slack channel. Please stay in touch and we'll have announcements. Just a little bit of logistics. The event is happening in 3 different buildings. So we have this, the auditorium. We have the library next door, which will have the booths and the coffee. And we have the annex, which I believe is this way, which will host the other sessions. So this is the event space. And finally, we have also the breakfast, lunch, and dinner happening in the social campus, which is that way. Okay, thank you so much. So before we move on to our credible first keynote, I'm going to allow Dada to actually introduce some of the guests from Senegal AI ecosystem. Thank you.
Thank you, Emily. we have the Ministry of Higher Education, Research and Innovation. Please make some noise for him. Keep clapping, please. Mm. Okay, so I will just introduce our guests. Our guests is, so we have the Ministry of Higher Education, as I said. We have the rector of the university, Mr. Ibrahim Sise. We also have the director of the social campus, Mrs. Fatima Dian. We have the representative from the Ministry of Telecommunication, Communication and Digital, Mrs. Aïssatou Jeanne Ndiaye. And also we have the French Embassy representative, Mr. Florian Blasi. So just clap your hand for these guests. Thank you. We will start with the speech that will be given by those guests. So we will introduce the rector of the university, Mr. Ibrahim Sise. Mr. Sise, please, you can go. If you would.
Merci, Daouda. L'université Amadou Mahtar Mbow, plus qu'une formation, un avenir à construire. Monsieur le ministre de l'Enseignement supérieur, de la Recherche et de l'Innovation, Madame la représentante du ministre de la Communication, et des Technologies, Monsieur le représentant de l'ambassadeur de France, Mesdames, Messieurs, en vos titres et grades, c'est avec un immense honneur et une grande fierté que je me tiens devant vous aujourd'hui en tant que recteur de l'université Amadou Mahtar Mbow pour le lancement de ce prestigieux sommet de Deep Learning Indaba 2024. Accueillir cet événement de renom mondial au sein de notre institution n'est pas seulement un privilège, mais aussi une reconnaissance de l'engagement de l'Afrique dans le domaine de l'intelligence artificielle et de l'apprentissage profond. Le choix de notre université comme hôte de ce sommet témoigne notre vision et notre détermination à faire du Sénégal un hub intellectuel et technologique en Afrique de l'Ouest. Nous avons toujours cru en la capacité de l'Afrique à non seulement adapter, mais aussi conduire des innovations technologiques mondiales. Et ce sommet est une illustration concrète de cette ambition. Au cours de cette semaine, nous aurons l'opportunité d'entendre les plus grands esprits du domaine, de participer à des ateliers de pointe et surtout de partager des idées qui façonneront l'avenir de l'intelligence artificielle sur notre continent et au-delà. Le deep learning, avec son potentiel à transformer tous les aspects de notre vie, de la santé à l'agriculture, en passant par l'éducation et la finance. Mais aussi, le deep learning est un levier stratégique pour le développement durable et inclusif de nos sociétés. À l'Université Amadou Mahtar Mbow, nous croyons fermement que l'intelligence artificielle ne doit pas être une simple importation technologique. Elle doit être réappropriée, contextualisée et utilisée pour résoudre les défis spécifiques auxquels nous faisons face en Afrique. C'est pourquoi nous avons fait de la recherche en intelligence artificielle et en deep learning une opportunité dans nos programmes académiques. Et nos projets de recherche, pareil. Nous aspirons à former la prochaine génération de chercheurs et de praticiens africains qui contribueront activement à l'essor de cette discipline. Je tiens à remercier chaleureusement les organisateurs du DIP pour avoir choisi notre université comme lieu de cette édition. Votre confiance nous honore et nous encourage à poursuivre notre mission de promouvoir l'excellence académique et l'innovation. Je remercie également tous les partenaires, les chercheurs, les étudiants et tous ceux qui, de près ou de loin, ont contribué à la préparation de cet événement prestigieux. Ensemble, nous avons l'opportunité de tracer la voie vers le futur où l'intelligence artificielle, ancrée dans nos réalités, servira de développer ou le développement de l'Afrique et renforcera sa position sur la scène mondiale. Je vous souhaite à tous un sommet riche en apprentissage, en découverte et en collaboration fructueuse. L'Université Amadou Mahtar Mbow, plus qu'une formation, un avenir à construire. Je vous remercie.
Thank you, Mr. Cissé. Make noise, please. Okay, perfect. So we will go to the next guest, Mr. Florian Blasi, Associate Professor. Sorry, yeah, Mr. Florian Blasi from the French Embassy.
Monsieur le ministre de l'Enseignement supérieur, de la Recherche et de l'Innovation, Madame la directrice, représentante du ministre des Télécommunications et de l'Économie numérique, Monsieur le recteur, Mesdames, Messieurs, membres de l'équipe organisatrice du Deep Learning Indaba, Mesdames, Messieurs. Il était très important pour moi d'être présent ce matin en tant que chargé d'affaires de France pour l'ouverture officielle de la 6e édition du plus grand rassemblement de scientifiques et d'acteurs de l'écosystème d'intelligence artificielle du continent africain. Pour la première fois, cet événement est accueilli par un pays francophone, le Sénégal. C'est un signe clair de la dynamique propre de l'écosystème sénégalais de l'intelligence artificielle. parce que le Sénégal fait partie des rares pays du continent à s'être doté à la fois d'une stratégie nationale des données, d'une stratégie nationale de l'intelligence artificielle. Et c'est aussi le seul pays du continent à avoir rejoint le partenariat mondial de l'intelligence artificielle. L'organisation du Deep Learning Indaba au Sénégal, c'est aussi le fruit d'un engagement remarquable, celui d'une équipe de l'association Galsen AI et de ses cofondateurs, également membres de la présidence du Deep Learning Indaba, messieurs Daouda Djiba et Dergen Mbaye, que je vous propose d'applaudir également chaleureusement. Bravo à eux. Sachez, messieurs, que c'est un honneur d'avoir pu nouer un partenariat avec vous dans le cadre de cet événement afin de soutenir votre mission tellement importante. Je souhaiterais également remercier Monsieur le ministre de l'Enseignement supérieur, de la Recherche et de l'Innovation, ainsi que le recteur de l'université, pour leur accueil et cette invitation à prendre la parole. Cette invitation, elle témoigne des relations soutenues que nous entretenons, France et Sénégal, autour des grands enjeux de l'innovation dans le secteur du numérique au Sénégal. Monsieur le ministre, monsieur le recteur, vous pouvez compter sur l'engagement de l'équipe France au Sénégal sous l'autorité de l'ambassadrice de France, Christine Fage, pour mettre en œuvre la volonté commune de nos deux présidents exprimée lors de leur rencontre à Paris en juin dernier. Je vais les citer. Ils nous demandent de donner une nouvelle impulsion au partenariat entre le Sénégal et la France, fondé sur un respect mutuel, un partenariat équilibré au service des intérêts réciproques des deux peuples, unis par des valeurs démocratiques partagées, par un lien humain et une relation d'amitié. Et ils nous demandent de renforcer la coopération dans les secteurs qui contribuent à une plus grande souveraineté du Sénégal. C'est bien sûr typiquement le cas de l'intelligence artificielle. Mesdames, Messieurs, l'organisation du Deep Learning Indaba ne pouvait pas mieux tomber, puisque l'Union africaine vient d'adopter il y a quelques jours sa stratégie continentale pour l'intelligence artificielle. Ce qu'elle vise, c'est ce que vous avez déjà évoqué, monsieur le recteur, c'est de permettre de s'approprier pleinement sur le continent africain les bénéfices de cette révolution majeure en cours. Alors que cette stratégie rappelle l'importance de promouvoir la recherche et l'innovation par le développement de partenariats entre la sphère scientifique, les secteurs privés et publics, à travers la coopération internationale, le Deep Learning Indaba, qui coche toutes ces cases, s'impose comme un événement incontournable. Mesdames, Messieurs, l'intelligence artificielle, c'est bien plus qu'une nouvelle technologie, c'est la promesse d'une nouvelle manière d'interagir avec notre environnement. Si elle n'est pas nouvelle, son essor s'est toutefois affirmé ces dernières années avec la croissance des puissances de calcul, celle exponentielle des données et des capacités de stockage. Son développement est la source de toutes les attentions, tant les opportunités qui lui sont associées sont nombreuses, vous le savez, en termes de croissance économique, de développement des affaires, mais aussi de réponse aux défis globaux comme la santé publique, la sécurité alimentaire ou le changement climatique. Néanmoins, les défis propres à l'intelligence artificielle ne doivent pas être sous-estimés. Alors, j'écarterai tout de suite la crainte de la singularité imaginée par les auteurs de science-fiction et également certains acteurs majeurs de l'intelligence artificielle, ce point de bascule dans lequel la machine surpasserait et dominerait les humains. Il semble que nous n'y sommes pas encore. J'écarterai également l'avènement de la psychohistoire, pour ceux qui connaissent ce roman de fondation d'Isaac Asimov, dans lequel cet auteur visionnaire imagine une sorte de préfiguration du big data avec un algorithme tellement puissant qui permettrait d'imaginer, de prévoir le futur de l'espèce humaine. Nous n'y sommes pas encore tout à fait, semble-t-il. Mais il y a d'autres risques et défis associés à l'intelligence artificielle qui sont, pour le coup, avérés. J'en citerai 3. Une IA qui décevrait, une IA qui serait déresponsabilisante ou une IA qui serait plus destructrice que créatrice d'emplois. Le premier risque, qui peut paraître paradoxal, mais qui ne doit pas être sous-estimé, c'est celui de la sous-exploitation de l'IA ou de la non-appropriation. Elle pourrait aboutir à un nouveau paradoxe de Solow. Solow, c'est cet économiste prix Nobel des États-Unis d'Amérique qui avait déclaré en 1987 « Les ordinateurs sont partout, sauf dans les statistiques de productivité ». Cette sous-exploitation exploitation, elle pourrait provenir d'un manque de confiance dans l'intelligence artificielle, d'un manque d'investissement, d'un manque d'infrastructure. Le premier impératif, c'est donc de continuer à investir, de favoriser l'acceptabilité sociale, sa diffusion dans l'ensemble de l'industrie, car on le sait, la capacité d'une nouvelle technologie à changer les choses, à donner un nouvel horizon à l'économie d'un pays, c'est sa diffusion de l'état de l'art dans tous les secteurs susceptibles d'en profiter. Le deuxième risque, plus facilement identifié peut-être, c'est celui d'une intelligence artificielle opaque, déresponsabilisante, aveugle à ses impacts, notamment environnementaux. On commence à aborder ce sujet du niveau de consommation électrique, de la puissance de calcul qu'il faut. Ce ne doit pas être un sujet qui doit être ignoré, c'est vraiment un sujet qui doit être au cœur des réflexions précoces sur l'intelligence artificielle. Et puis bien sûr, vous êtes des spécialistes, il y en a dans la salle, ce que je ne suis pas, mais ce que je sais, c'est que les résultats produits par l'intelligence artificielle dépendent de la façon dont elle est conçue et dépendent également des données qu'elle mobilise. Or, ces processus peuvent être consciemment ou inconsciemment biaisés et donner ces fameuses hallucinations, ces erreurs de l'intelligence artificielle. C'est pourquoi l'intelligence artificielle publique, dite de confiance, doit être encore fondée sur le principe de primauté humaine qui seul permet la responsabilisation. Le troisième risque que je souhaite citer, c'est celui d'un manque d'anticipation de l'impact de l'usage de l'IA sur le marché du travail qui pourrait créer une nouvelle fracture sociale. Et là, l'enjeu, il est celui de l'enseignement supérieur, bien sûr, des institutions de formation qui doivent s'adapter, se mettre au niveau, former la nouvelle génération. J'en citerai un dernier, très important aussi, c'est le risque d'une concentration de l'IA dans quelques acteurs du secteur privé, issus principalement d'un seul pays, un vrai sujet de souveraineté pour tous nos pays. Ces défis, la France cherche à les relever. C'est pourquoi nous nous sommes dotés d'une stratégie nationale en 2018, accompagnée d'un plan d'investissement de 2,2 milliards d'euros. Le président Macron a par ailleurs annoncé lors du dernier sommet Vivatech un nouvel effort de 500 millions d'euros, avec pour objectif de renforcer considérablement la puissance des supercalculateurs français et la création de 5 à 10 pôles de recherche et de formation de rang international. Mais sur un sujet pareil, à dimension mondiale, quelles que soient nos ressources, nous avons en France des mathématiciens de rang mondial, mais seul un diagnostic partagé et des pistes d'action valables par-delà les frontières ont du sens. C'est pourquoi nous nous réjouissons de travailler avec le Sénégal, d'accueillir bientôt le sommet pour l'action sur l'intelligence artificielle et également de voir l'Union africaine s'emparer pleinement du sujet. Nous sommes fiers de pouvoir contribuer au développement de la trajectoire sénégalaise de l'intelligence artificielle et nous sommes bien entendu disponibles pour continuer à en faire un axe de collaboration important entre nos deux pays. Stratégie nationale, stratégie LUA, mais donc ce niveau mondial, et c'est pourquoi la France accueillera les 15 et 16 février 2025, dans la continuité des sommets de Blenheim Park et de Séoul, le sommet pour l'action sur l'intelligence artificielle. Le maître mot de ce sommet, c'est la co-construction entre tous les acteurs du secteur public, du secteur privé, les gouvernants, les spécialistes, les entreprises. Et nous espérons une participation active du Sénégal et du continent africain à la mesure de la place qui leur revient sur ces enjeux majeurs. Mesdames, Messieurs, je vous souhaite à tous de fructueux échanges lors de cette édition au thème si inspirant, Ham, Hamlé, savoir et faire savoir. Je vous remercie.
Merci. Thank you, Mr. Blasi, for this speech. Really inspiring. Let's now welcome our next guest from the Ministry of Telecommunication, Communication and Digital, Mrs. Aïssatou Jeanne Si.
Monsieur le ministre de l'Enseignement supérieur, de la Recherche et de l'Innovation, Monsieur le ministre conseiller de l'ambassade de France, Monsieur le recteur, Mesdames et Messieurs les invités, chers participants, je suis honorée de représenter le ministre Monsieur Alioune Sall, ministre de la Communication, des télécommunications et du numérique, empêché à la cérémonie d'ouverture de la 7e édition du Deep Learning Indaba. Cet événement est une célébration de l'innovation, de la collaboration et de l'esprit pionnier qui caractérise notre continent. L'Afrique est à un tournant décisif. Avec une population jeune et dynamique, nous avons l'opportunité unique de façonner notre avenir grâce à l'intelligence artificielle et aux technologies émergentes. Ces outils ne sont pas seulement des moteurs de croissance économique, mais aussi des leviers pour résoudre certains des défis les plus pressants auxquels l'Afrique est confrontée, tels que l'accès à l'éducation, aux soins de santé, à l'énergie et au développement de l'agriculture. Et c'est pourquoi, afin de tirer plein profit de cette technologie, le Sénégal, à travers le ministère de la Communication et des Télécommunications et l'écosystème numérique du Sénégal, en collaboration avec des partenaires techniques, a finalisé sa stratégie nationale sur l'intelligence artificielle. Cette stratégie répond aux enjeux de la souveraineté technique qui passe par une maîtrise de la population, de la maîtrise de la production des futurs services IA pour être adaptés aux priorités et besoins nationaux, à la maîtrise de la culture, de la langue locale, mais aussi une maîtrise de l'origine des données d'entraînement. La souveraineté numérique du Sénégal sur l'intelligence artificielle requiert une mise à niveau du système de formation, un soutien à la recherche, à l'innovation et à l'entrepreneuriat, la mise à disposition de données locales massives et d'infrastructures de calcul intensif, une adaptation au cadre juridique au risque de l'intelligence artificielle, mais également ainsi que des alliances régionales et internationales dans les domaines techniques, juridiques, formation et recherche. Et c'est pourquoi le Sénégal a été parmi les premiers pays d'Afrique à intégrer le partenariat mondial sur l'intelligence artificielle. La stratégie nationale de l'intelligence artificielle est structurée autour de 4 axes stratégiques. La formation de 100 000 talents en intelligence artificielle et données d'ici 2028, mettre en place un cluster national avec des compétences locales, mettre en place également des alliances régionales et internationales et faire une IA éthique et de confiance pour tous et qui intègre la mise en place d'un cadre juridique adapté, un pilotage adapté, de la régulation et également de la sensibilisation. Mesdames et messieurs, aujourd'hui nous sommes réunis pour partager nos connaissances, nos expériences et nos visions. Nous sommes ici pour apprendre les uns des autres et pour construire des ponts entre les différentes communautés technologiques de notre continent. Ensemble, nous pouvons créer des solutions innovantes qui répondent aux besoins spécifiques de nos sociétés. Je tiens à remercier tous les organisateurs, les sponsors et les participants qui ont rendu cet événement possible. Et je vous encourage, au nom du ministre Moussa Alioune Sall, tous à profiter pleinement de cette opportunité. Participez activement aux discussions, posez des questions et partagez vos idées. Et surtout, soyez inspirés. Ensemble, nous pouvons transformer notre continent et créer un meilleur avenir pour tous. Votre engagement et votre passion sont la preuve que l'Afrique est prête à prendre sa place sur la scène mondiale de l'innovation technologique. Je vous remercie de votre aimable attention. Merci beaucoup.
Merci. Thank you, Mrs. Aïssatou Jeanne Ndiaye-Si. We will go to the next speech, which is the Minister of Higher Education, Research and Innovation, Mr. El Hadji Abdourahmane Diouf. Please welcome.
Bonjour à tous. Madame la représentante du ministre de la Communication, des Télécommunications et du Numérique du Sénégal, Monsieur le ministre conseiller auprès de l'ambassade de France au Sénégal, M. Blasi, Monsieur le recteur de l'UAM, la plus belle université du Sénégal, Mesdames et Messieurs, Madame la directrice du CROUS, Mesdames et Messieurs, chers intervenants et chers participants, en vos rangs, titres et qualités. Je vous adresse mes salutations les plus distinguées et les plus chaleureuses. C'est avec un immense plaisir que je vous souhaite la bienvenue au Sénégal. Notre pays est honoré d'être l'épicentre de l'écosystème de l'intelligence artificielle en Afrique avec cette 6e édition du Deep Learning Indaba 2024. Nous nous réjouissons d'accueillir ce prestigieux événement du 1er au 7 septembre ici, à l'université Amadou Mahtar Mbow, qui est l'un des démembrements du ministère de l'Enseignement supérieur, de la Recherche et de l'Innovation. Les nouvelles orientations en termes de politique publique du président de la République, Bassirou Diomaye Faye, et du gouvernement en matière de formation et d'enseignement supérieur, et surtout en matière de recherche et d'innovation, impliquent une montée en puissance progressive du numérique et de l'intelligence artificielle. Notre gouvernement a récemment validé et mis en œuvre une stratégie nationale d'intelligence artificielle, une étape cruciale vers le renforcement de notre écosystème local. Donc, le ministère de l'Enseignement supérieur, de la Recherche et de l'Innovation soutient pleinement une telle initiative. Il est disposé à soutenir et à travailler avec la communauté à renforcer l'intelligence artificielle dans l'enseignement supérieur. L'ambition est de placer l'Afrique à la pointe de l'innovation technologique en nous mettant à niveau en termes d'équipement matériel, en soutenant la création de contenus socialement et culturellement adaptés, en proposant des solutions locales à nos problèmes, en alimentant l'architecture AI avec nos propres données et inputs. Et il y a derrière cela un enjeu de préservation de valeurs, de l'identité et de l'héritage culturel africain. Parlant de valeurs, la mission du Deep Learning Indaba s'aligne harmonieusement avec l'esprit de générosité et de partage de la teranga sénégalaise. En effet, le thème de cette année, en Wolof Xam Xamle, qui signifie s'armer de connaissances et les partager, résonne profondément dans les valeurs de notre pays et les objectifs de notre ministère. Par ailleurs, nous invitons tous les acteurs, organisateurs et souteneurs de ce présent événement à s'impliquer activement dans l'organisation de ce qu'il est convenu d'appeler le Salon international de l'innovation et des inventions que nous prévoyons d'organiser à Dakar en 2025. Nous voulons donner à cette dimension innovation une dimension mondiale, un rayonnement international. Le choix du Sénégal comme hôte de cette édition du Deep Learning Indaba 2024 est un témoignage de la vitalité de notre écosystème technologique. Nous abritons l'une des communautés Indaba X les plus actives dans les organisations innovantes, telles que Galsen AI et AI Hub Sénégal. Et nous félicitons toute la communauté AI sénégalaise, mais aussi celle africaine en général, pour son dynamisme et sa proactivité. Cette présente édition, qui rassemble plus de 700 participants de 47 pays africains, rejoint par des invités en provenance du monde entier. Cette diversité illustre la puissance de la collaboration panafricaine et internationale dans le domaine de l'IA et du machine learning. À l'instar de Cheikh Anta Diop, qui invitait la jeunesse africaine à se former et à s'armer de savoir jusqu'aux dents, cet Indaba offre une opportunité de prendre en main l'avenir technologique de notre continent. Au cours de cette semaine, vous explorerez les fondements de l'apprentissage automatisé, vous découvrirez les dernières avancées technologiques et vous participerez à des ateliers spécialisés. Vous aurez l'opportunité de relever des défis africains lors des hackathons, de proposer de nouvelles idées lors des hackathons et d'échanger avec des chercheurs et des professionnels expérimentés. Avant de déclarer ouverte cette session, je voudrais juste dire 2 à 3 mots. Je vous ai parlé tout à l'heure de la possibilité d'organiser un salon de l'innovation et des inventions au Sénégal dès l'année prochaine. Cela résulte des instructions du président de la République qui voudrait que le ministère de l'Enseignement supérieur, de la Recherche et de l'Innovation ne soit pas simplement le ministère de l'Enseignement supérieur. Le Sénégal doit monter en puissance en matière de recherche et d'innovation. Nous avons commencé des travaux de benchmarking et à ce jour, nous avons ciblé 3 salons privilégiés sur lesquels nous pourrions nous appuyer en termes d'expérience et de partenariat pour faire de Dakar, dès 2025, le hub de l'innovation. Naturellement, il y a Vivatech à Paris, qui nous inspire beaucoup, qui nous intéresse beaucoup, et nous voudrions entamer des discussions pour voir comment ça se fait, comment ça s'organise, pour pouvoir mieux l'écrémer et l'importer au Sénégal. Nous avons aussi fait ce travail de benchmarking avec Genève. Genève, qui a le salon de l'invention et des innovations, qui est le premier salon du monde, et qui est aussi prêt à être un partenaire avec le Sénégal pour pouvoir organiser ce salon de l'innovation ici. Il y a aussi Hong Kong, qui travaille beaucoup avec Genève sur cette question, et toutes les autres grandes villes du monde qui ont cette ambition. Nous voulons travailler avec eux pour que dès 2025, Dakar et le Sénégal en général puissent se positionner comme un hub. Donc nous tendons la main à tous les partenaires qui sont ici présents pour commencer ces discussions, pour que ça ne soit pas seulement un salon africain, mais que ça soit un salon international de l'innovation et des inventions. Naturellement, avec tout ce que cela comporte de déclinaison en termes d'intelligence artificielle, de propriété intellectuelle et de protection des brevets. J'ai aussi un mot pour cette jeunesse africaine qui est ici présente. En tant que ministre de l'Enseignement supérieur, je vous souhaite la bienvenue. And I would like to just say just 2 words about our friends coming from English-speaking countries, to say them you are welcome in Senegal. From my professional life within African countries, I just understand that you don't have to discuss, you don't have to think, about French-speaking countries and English-speaking countries. You are just African, you have to focus on African issues, and you have to do the best for our continent. Another issue which is very important for me also, I think that no more we don't have to talk about lawyers, scientists, or others. Our opinion is that if you are a young African in this new world in 2024, you have the potential to be a scientist. Don't be in this line saying that I am doing literature, I'm doing philosophy, I'm doing something else, and I am not able to have some skills on artificial intelligence, for example. You can do it. You can do it, and you'll do it. And I think that you can rely on our experience as African trying, and I can say this kind of thing in front of our French friend. In this new world, if you are a young African, what you have to do is to rely on your tradition. You rely on your knowledge, but you have also to go in France and to take the best in France, the best in Switzerland, the best in USA, the best in Canada. And you have to gather all these things and to come back in Africa and to build a new Africa. This is what we expect from you. Donc voilà ce que je voulais dire. Merci encore à tous les partenaires et sachez que nous sommes à votre disposition pour le futur. Je vous remercie.
Thank you so much for all of our speakers. For all the photographers, we would like to continue with our program. Could we please do the photographs outside of the main stage? We've got a keynote speaker. Could we continue with the photographs outside of the main stage?
Okay, we start. Hello. Slide, please. Okay. Thank you so much. Hi, everyone. Good morning. So just quick update about the program. So I think the printed program is not up to date. If you can scan this QR code, it will give you the update program. I think some of you were not here yesterday. So please do scan this program and keep it with you. You will have all the information. Okay. Another slide. Next. Okay, so we have a mentorship session happening every day during the lunchtime and during breakfast time. For that one, you need to sign up. I know we already announced this before, we send it, but please do sign up because we will arrange breakfast and lunch. So we need to know the number of people who are attending that session. Yeah, please do sign up and we'll confirm your attendance by email. So we're supposed to have a coffee break at 10:30. So because we are late, we will have the coffee break at 11. Like it will be parallel with the practical. So you just go and pick your coffee and snacks and come here for the practical, okay? So now we'll start by the keynote, first keynote for this week. Isabel, she's here. Thank you so much. Yeah.
So one quick also update. During the week, we'll be using auditorium for all the keynote session, and we're using the auditorium and annex rooms. I think some of you don't know where is annex, but it's going to be behind the auditorium in the other building, the white rooms. That will be for tutorial and practicals. Okay, so this is the 4 rooms we will be using. All the coffee breaks are happening behind the sponsor area, and then the lunch is going to be in the social campus. Thank you so much.
Cool. So before I introduce Isabel, just to note, so that's Aisha from PC. I'm Kira from PC. If you have any problems, find someone in a red t-shirt. About the practicals, so they're going to start, as Aisha said, at 11. They'll go until 1. If you sign up for mentorship, it might be good to leave a little bit early, grab coffee during the practicals. We've noticed that the internet in the auditorium is not so great, so I have put on Slack, if you want to attend Responsible AI here, try and download it in advance or find a friend who has a hotspot. The other practicals will be in the annexes, diffusion models, LLMs, and RL. Great. So that's all done. I'm very pleased to introduce Isabel Valera. She is a professor at the Department of Computer Science at Saarland University in Saarbrücken in Germany. She's also part of ELIS, the European Lab for Learning and Intelligent Systems, and she's previously been at the Max Planck Institute in Tübingen and has contributed really greatly there. We're really, really happy to have her here. We think she's going to give us a great introduction and a great keynote to start off this deep learning Indaba. So let's all give her a warm welcome. She's going to speak to us about cause ethical ML. Isabel, please join us on the stage.
Okay, so hello, good morning everybody, and thank you very much for having me here. So today I'm gonna try to start and follow the motto of this workshop and conference, which is I'm gonna try to share some of the knowledge I have acquired through one of my projects, called Ethical Machine Learning, and I'm gonna try to share it with you, to transfer it with you. So let me start a bit with a bit of the motivation. And as a machine learning developer, it is quite common that we focus very much on the performance of our algorithms. But then when we deploy them in real life, it's very important that they fulfill a set of desiderata, right? And everybody should have heard by now the need of having interpretable models, the need of having fair models, making sure that our models, when we deploy them, for example, for e-commerce, they are respectful to consumers and also product deployers. So it's kind of important that it's not only a matter of measuring accuracy, as we very often do in machine learning conferences, but there are a set of properties that are essential for us to guarantee in order to deploy them in real life. However, if we look at the news, and these are, I always forget, I don't have a clicker. So if we look at the news, and these news are from the 2017 to the 2020, roughly, and they are all in the context of fairness, because it's one of the topics where I basically put most of my efforts. You can see that there are many news here, and many more that I didn't list here, about the unfairness or the biases of these algorithms. And one can think, well, but since 2020, many things have happened. Can you go next? And the truth is that there are more and more new technologies, and now in the era of generative AI, one may think that the problems, the issues, the ethical issues with these technologies may have gotten also better, right? Because we are deploying new technologies, and we already knew that there were some ethical issues with them. But the truth is that that doesn't seem to be the case. And if we look at the, I don't know what happened here. And if we look at I need to be 2 slides further. Thank you. And if we look, for example, at the UNESCO report from March this year, it's already still talking about not only generative AI preserving biases and fairness patterns in the society, but also amplifying them to the level of calling them perversive. So it seems that we are not quite there. So what I'm going to talk about today, next, is how can we use causethical, what I call causethical machine learning, to improve a responsible AI technology development. So let me start with the concept of causethical, and basically the idea is to transform the desiderata of ethical machine learning, in particular in the context of explainability and fairness, into causal inference questions. Next. So for that end, let me focus, and I don't know why some of my slides don't seem to be complete, but basically, simply follow my wording and we will do our best. Let me start with, for the sake of simplicity, with an algorithmic decision-making system, which I have simplified a lot. And basically, we have an algorithm that decides automatically or filters out automatically curriculum, CVs. So when you apply, for example, to a high-tech company, there might be an algorithm behind that decides whether there will be a human being looking at your resume or not. And let's consider that we want to question, or we have questions regarding the fairness and the explainability of this algorithm. So we might want to consider whether the algorithm may discriminate based on gender. And what does a particular applicant, which I call here Alice, will need to do in order not to be filtered out, in order not to be automatically rejected next time she applies. And the question here is that very often, when we look at the current developments of machine learning, we think that more and more data may have the solution. But the truth is that that might not actually be enough. And in this talk, what I'm going to argue is for the fact that only data doesn't suffice to fulfill all the desiderata beyond accuracy. It might very well be, although it's also questionable, that for higher performance in the way that we have to measure the performance of our algorithms, more data might suffice. But for ethical questions like fairness or explainability, that's definitely not enough. So the question would be, what kind of data or information do we need from these models? Well, the first thing that one needs to consider is that if we have such an algorithm which makes decisions on whether some CV is going to be considered or not, even if the gender information that doesn't enter in the algorithm, we have already seen many cases in which there might be spurious correlations between, for example, the job and the education level of the individuals, and the algorithm can learn to make decisions directly on that. So even though gender might not be there, there might be what I'm going to call here today a causal relationship between some socio-demographic information, gender here, and the features that we observe and use to train our algorithmic decision-making. And the question is, how do we systematically answer these questions, right? We need to assess whether the algorithm is discriminatory, and we need to provide what we are going to call today rejected. So we need to give them actionable explanations. So something I would like to point out today is that these kind of questions, like for example fairness, can be actually formalized as a population level cause-effect question, where we might want to consider two hypothetical worlds, one of them which is only male applicants, one of them which is only female applicants, and compare how the system behave, or whether the system behave differently for the two populations. For those familiar with the fairness literature, this definition I'm writing here, where basically I compare the probability of accepting an applicant in a world where all the people are males versus a world where all the people are females is actually resembles the counterfactual fairness notion proposed by Kushner et al. In 2017. It's simply a different way of writing it. So the question is, how do we actually can compute or estimate this kind of bias or unfairness? Next. Similarly, if we have Alice who wants to understand what to do, how to improve her curriculum, in order to get accepted next time, she might want to wonder, I moved too much apparently. She might want to wonder whether having a PhD or investing her time and effort, all of us may know that actually growing into your study career takes quite significant time and effort. And she might be worth knowing beforehand whether that effort is worth it for building up towards the profile that she wants to build, right? And that would mean that before she starts getting a PhD title, she would like to know whether she's moving one step forward into getting accepted for the type of position that she's interested on. So next. So now the question is, what do we need for causative machine learning? And as I said, unfortunately, data is not enough. By now, you should have a bit of an intuition of where I'm gonna move. Next. And actually, this is my most technical slide, so I really hope you can follow me here. From then on, I will try to keep the math limited. But basically, the first thing that we need, as you may see, is to get a bit of an understanding of what is the relationships, the causal relationships between our input features. So it's not that we can consider features like they don't have anything to do with each other, but we are going to need to have an understanding of how different features affect each other. So for example, how does gender affect the education level of individuals, and how an educational level may affect which job opportunities individuals may have to ultimately process how they can develop in the future when they apply to new positions, right? Of course, in general, we have a pipeline, very mathematical pipeline introduced. I'm following the one by Pearl from UCLA, where basically we say that if we have a structural causal model, where we only don't have the causal graph, which is this graphical representation, but we also have the structural equations that say exactly how many different variables relate to each other, we actually, next, are going to be able to see how acting on the system, on the data generation process, will affect the world that we observe, right? It allows us to reason about different hypothetical worlds. The problem, next, is that, good news, in theory, we have a mathematical framework. The problem is that in practice, this mathematical framework has assumptions that we cannot often fulfill in reality. Because if we would know how the whole world works, specifically how society moves and how different societies move and how the different variables relate to each other, probably our life would be easier because we could target for them and optimize for that, but that is usually not the case. So everything that we can afford, or where I'm trying to move, is to see, okay, it seems that the causal framework is a good mathematical tool for reasoning about cause effects and about how we can change or perform actions in the world. But the question now next is, how can I do next that in practice, right? How can I reduce the assumptions on the knowledge I need to have about the world in order to ensure a development of machine learning that is more ethical? And this is where I'm moving and where actually deep learning is going to play a role. So several groups, including my own group, we have been working on developing what we call causal generative models. So just for your information, the goal of a generative model, all of you know, is to generate samples that look like real-world samples that we have collected from the data, right? So we are trying to mimic the underlying data generation process. We have seen that recently in the vision domain. We have seen that in the language domain with numerous applications. But here I want to go one step beyond, and I don't want to only generate data that looks like the one that we observe in the real world. I want to also be able to generate data that mimics or approximates what would happen to the real world if we would perform actions on the world, right? I want to reason about what would happen if Alice would have had a PhD. And I also want to reason about a world where all the population would be treated as males versus what the world would be if all people would be treated as females, right? So this is going to be my work. Can you go a bit backward? Thank you. Backward, backward. That was a bit too fast. So the idea or what we want from these generative models is not only to generate data as we do, but we also need to generate what it is called interventional and counterfactual data, which is how every individual will look after an action on this individual. Alice getting a PhD, this is counterfactual, as well as how the world will behave if everybody, for example, would be a female, right? And in order to do that, there are some theoretical properties that we need to fulfill because unfortunately, this is not like in clinical studies that you can do a randomized experiment in a very controlled setting and say, okay, to this part of the population I give medication, to this one I give placebo. Unfortunately, the societal cost of that randomized experiments in this kind of applications I'm talking about is either infeasible or too high because you cannot make the whole population male or female, for example, or from a continent or a different continent. In the same way as it might not be possible to ask people, okay, you do a PhD, invest your money and your effort and your time, and we will see what happens, right? For the sake of a study, because we are not talking about something short-term and something that is so easy to keep under control. So what we have done in this context, and I'm not going to enter next into many technical details, is to propose or extend generative models, for example, generative models based on Gaussian processes, variational autoencoders, or graph neural networks, to actually have generative models that fulfill these three properties. And for example, in one of our latest works, the causal normalizing flow, we managed for the first time to have theoretical guarantees that actually say that the data at the three levels that we are generating, so remember observational, interventional, and counterfactuals, actually fulfill the properties that we need. We have tested and we keep testing that on different applications in the medical domain, in the lending scenario, to see how far we can reach. So simply consider that when I started here, I talked about the problems of generative AI, and now I'm saying now I'm going to use a generative AI in order to address these problems. So the question is, how can we do that, right? And I said, well, maybe generative models, we need one step further. And I said, we don't need only data, but we need some assumptions about the world. We might need to know how our variables relate to each other. And this is necessary information for our generative models to fulfill the properties that I just mentioned. These ones and a few more assumptions, which are a bit more technical and not going to enter in here. So the question is that for the time being now, believe me, that we have a causal generative model that we can trust. So how can we use it for the first goal that I have it, right? Let's have a couple of examples, both in the context of fairness and explainability. If you are interested, there are many more examples also, for example, in the context of robustness, accountability, outside my group, but I can give you pointers after the talk, where actually we show how this additional bit of knowledge in the form of causal graph, for example, can support us to have some of the desiderata I have on my first slide. Next. So let's now focus on how we can measure and ensure fairness of ML algorithm development. Next. So let's go back to a decision-making example, this time in the context of lending. I don't know whether you have entered online banking and every now and then you get one credit offer. It depends very much on the country. Some of them, they offer you, today you have a credit of 3,000 euros. In my case, I work in euros, right? And there are some people that may get rejected. And then individuals who, by the way, have the right to issue a bank if they think that they have been discriminated and they have proofs, may consider whether this individual may have been discriminated based, for example, on gender, ethnicity, country of origin, or simply being an immigrant in a country. So the question, or what I have shown you before, is that actually this actually happens, and we have seen cases where systems, algorithmic systems, discriminate. But now the question next is, how do we make sure that together with our algorithm, we get some sort of warranties, in the ideal case, certification, saying that the algorithmic development has been assessed at every stage in order to measure and correct for discriminatory biases, right? And when I say the whole process, I'm talking about what it is called procedural fairness. It's not only a matter of the final decision, but the whole process. And keep in mind that when we talk about processes in machine learning, our process starts with the data collection process and finishes with the final decision, but everything in between, all the engineering decisions, are part of the process. Right? So you really need to monitor and keep track of everything going on. And not only that, but also being able to measure and when necessary, correct. So, next. How do we do that? It's a big open question. I have been working on the fairness literature for, I would say now, maybe 8 years, something like that. And we have done a lot of metrics of what we call observation and fairness measures and constraints that help us to assess, for example, the error rates across different groups of the population to see if an algorithmic decision or an algorithm might be discriminatory. But the problem that we have actually encountered is that these kind of algorithms incentivize or have the belief that there is an implicit or an explicit trade-off between accuracy and our ethical desiderata, like fairness. However, there have been already a few lines of work saying that this trade-off doesn't need to directly exist, but it's more a result of how we formalize the problem, right? So where I believe that causethical machine learning can help is, first of all, on only having such a trade-off when necessary and when it exists, and then bring it up to stakeholders to decide what is a good trade-off for our, depending on the application domain. And second, correct the fact that because when we move into statistical or observational measures of fairness, we don't reason about where these biases come from, so the sources or the causes of fairness, but only the final result. I would argue that causality here can help finding what are the causes of fairness or unfairness in our case, and then help us to more systematically correct them. I'm going to now give you an example next. So, all my titles are very small, suddenly. It's written Fairness Beyond Binary Decision. So, something that it is important for those that are familiar with the fairness literature is that very often we have, I would say, oversimplified very complex decision-making systems to classification problems. When I said the hiring, it is a matter of whether the person, the CV, is accepted or not. When I talk about granting a credit or a loan, I said whether the person is granted the credit or not. But if you consider these processes, decision-making processes, they are rarely binary. When I'm granted a loan, I'm granted an amount, a duration, an interest rate. When I'm granted an insurance, a health insurance, I'm granted a particular coverage and a set of services, right? When I'm granted a job, I'm granted a job with working hours, with a salary, etc., etc. And the question I raised to myself recently, because I started looking at a lot of the data sets that we look into fairness, is where are all these treatment decisions, how you are treated? It's not whether you are granted the loan, but the loan terms are your treatment. Where do they go in our fairness machine learning pipeline? And to my surprise, we were treating them as features of the applicant. I wonder how many of you have control on your salary, or how many of you have had control on the interest rate of your credit, or the amount of money that you pay for your insurance. I would argue that this is not a feature of the applicant, this is a decision by the decision maker. So what I actually wonder is that if I look, can you go next, to the data generation process, here S is the sensitive feature, X is the applicant features, covariates, for example, salary, income in the lending scenario, properties, past credit history, and Z here represents the treatment, so for example, the loan terms. So what I argue here is that actually treatment decisions are subjects to discrimination. So if we overlook them in our machine learning pipeline, we might not be doing any better, even if we correct for biases in terms of the outcome or the decision, algorithmic decision. Second, this treatment discrimination may propagate towards what the data that we have collected and the historical labels, these labels that we like so much to use for classifying, right? So can we actually argue that my repayment probability, for example, for a credit, will be independent of the treatment I'm given by the bank in terms of interest rate, annuity, amount, and duration? If you look at any feature selection study, these are highly discriminative features in this pipeline. So we have already a sense that that is not the case. So what we actually did is that we can use a pre-trained causal generative model with some partial causal information, and actually we can measure whether there was any discrimination from the sensitive feature S, direct in this red arrow, or indirect in this green arrow to the treatment. And we can also measure how this discrimination may have propagated to Y, which is the label I observe, whether someone repaid or not the credit. It's not only that. In case of such a discrimination exists, the causal pipeline will allow us to correct for this source of bias, which, by the way, is the one that the bank is responsible for, because the bank doesn't need to be responsible for the arrow from S to X, which is how society distributes wealth, but it is definitely responsible of which treatment the bank gives to different applicants, right? And we might be able to correct for that and design fair algorithmic decision-making processes. Next. So just to give you an example, in the broadly used German dataset that we often so much use in the machine learning community, I'm quite certain that many of you may have played with that dataset for classification. And what we actually observe is that if we would have treated males as females, they would have gotten way less money and less duration of the credit. The opposite happens when we go from females to males. So if I would have been a male, I would have gotten more money and longer duration. So how does this affect into the repayment probabilities of the people? Basically, what we observe is that from the defaulting males, people that were granted the loan under these conditions, right? If they would have been given less money, less duration, 8% of them would have been able to repay. So one can argue here, because we always think that discrimination is something that happened to the protected group, and actually it is very common to consider this a case of positive discrimination, in this case of treatment, because we are granting males more money, and in principle they are applying for money. But what we always neglected is the fact that with the bank taking a bit of a higher risk on mails, right? Some of these mails, 8% of them, defaulted to repay because they were given a bit of a too high risk treatment. So this is a bit of a counterintuitive example because very often when we think of fairness, we think that the people that are suffering from these discriminatory patterns are always the minority groups and the protected groups. And actually that can very well be the case. But I would argue that ethically this case is also not a good case. So what can we do in order to correct for that? Actually what we saw is that if we would have given fair treatment decisions to males, everybody would have gotten better off because these people would have been able to repay, increasing the number of customers for the bank that would have been able to repay. So the loss given default by the bank, it's how they measure the defaulting credits, would have decreased. And at the same time, the clients would have also improved because overall they would have paid less interest rates. So why I want to show you this example is simply because we always very often think that fairness, explainability is a constraint to accuracy, ultimately money. And I would argue that very often that is not the case. That is only the case of how we formalize and reason about these problems. So please, when you consider developing your algorithms, more data, not making assumptions explicit is not the way to go. If we want an AI uptake and development that is beneficial for everybody, we need to do an extra mile. And this extra mile is reasoning on the properties of these algorithms in a systematic way. In my case, the systematic way I'm proposing today is based on causality. Am I saying that causality is the solution to everything? I would argue no. You can find your tool. I'm exploring, but it's worth the try. So can you go next? I've been asked to shorten a bit my presentations. I have a second example on the context of explainability. And can you go a couple of slides next? And something I wanna just, one more? Just mention, I'm not gonna enter into the details, is that these deep generative models allows us also to generate instantaneous actionable explanations together with decisions of the algorithms. So one can be able to not only generate a negative prediction, so someone is not getting the credit, but we are able to automatically, instantaneously also generate an actionable explanation for the individual to revert a negative decision. We believe that this is important because if we are able to make decisions at a scale, we should provide explanations at the same scale, and this is the direction that we are moving on. So if you are interested, please check our karma paper. My student picked a very interesting name from FACT last year, and maybe move to a slide, because I'm gonna skip that, to slide 35, please. 35? A bit farther, farther? Farther? Yeah, here. So what I hope I have convinced you so far is that a bit of extra information may help us to improve the explainability and the fairness of our algorithms, sometimes even their profitability, which I think is good for the owners of these algorithms. Next, but there are still many open questions, and I'm gonna can you go all the way to the full slide? It's gonna be a bit overwhelming, but I don't need to be doing next. Feel? Yeah. So something I would like to end up with is making sure that you understand that there are still many open questions here. And I think we are moving a step further, but we need to catch up. We cannot have a technology that develops much more faster in terms of performance than in terms of ethical and responsible values. So this is a picture of the generative AI life cycle. You can imagine I have been talking about keeping track of all the causes of unfairness. In the lending scenario, that was already complicated, but now look at this beautiful picture. It's not up for you to parse it, but more to see that there are too many steps. So the processes are not actually easy. Same happened with when we consider how can we provide faithful explanations for how this overall system reasons, how the information propagates, how the ultimate decision is being performed. There are many more open questions like how can we guarantee or even certify, because in some scenarios we may need to certify, like autonomous driving, that our system operates in a safe situation. How does this pipeline, because I said, well, we need data and additional information, but definitely we need data, because now I said, in order to move from a classifier and make it fair and explainable, I need a generative model. And all of us should know, or will know, hopefully this week, that generative models are even more data hungry than supervised models. So how do we even trade off that with the data minimization and privacy issues already out there in many laws, right? Where is the right trade-off? Is it okay to use more data in order for a more responsible development? Where is the threshold? That are all open questions. Same here happens when we think of how to account not only for the desiderata of the deployer, but desiderata from other stakeholders, like regulators. There is a big movement in the European Union about how to regulate AI, and it's all about measuring risk. How can we even keep track of risk? How can we measure? And how can we find acceptable trade-offs? But also the other side of the coin, how can we make other stakeholders or different stakeholders accountable for a system behavior? Ultimately, overall, the open question in which my direction is moving, and I hope several of you might be interested in maybe following up more personally in a discussion with me, is how can we do an AI, in my case, machine learning development, that is beneficial for all individuals, groups, states, continents, but overall society. So with that, you got a short version of my presentation. If you are curious, come talk to me. More details can come. Thank you very much. Next slide. And here you have my group if you want to gossip more on our ongoing projects. Thank you.
Thank you very much.
Any questions? Do we have time for questions? Yes. I was told 35 minutes. I think I should be fine. No question? Yeah, there is a question there.
Hi, thank you so much for your talk, really interesting. I was wondering if you've considered in your research looking at more sequential decision-making problems and how you might apply like causal models to explain those decisions.
That's a great question. That makes me very excited because one of the new lines of research I'm working is that the causality pipeline introduced by BERT works very well in the stationary setting, in snapshots of the distribution. And there is some efforts on the theoretical causal reasoning over time, but there is no practical direction. So I have an ongoing project on how to come up with a practical approach for causal inference over time that hopefully will come out soon. And I think this is a first step, because if we are going to make sequential decision making, we are going to assume that our distributions are not stationary but may change over time due to the interventions or the actions that we perform on the system, first things I need is a theoretical causal pipeline, but also practical pipeline that allows me to see how these actions, what effects these actions will have and how they will propagate over time in the short, medium, and long term. And these are definitely questions I'm looking into in the context of fairness, definitely. But still not quite there yet.
Thank you, Prof. I really enjoyed your presentation. And all along, I've been wondering about the usage of machine learning, most especially when people want to do anything with any of the algorithms. Most times, they can just go online to get open source data and possibly do whatever they want to do. But while you were presenting, you mentioned the fact that there is need for us to understand the problem that we want to solve, and thereby working on our algorithms. And that is to say that machine learning is not just only for the neuro AI, but also the neuro-symbolic AI. And so you talked about the formalization of the problem. Now, I want to ask, if we really want to formalize our problems, at what point do we do that? Because, and then in formalizing the problems, at what point again do we work on our algorithms? At what point do we formalize the problem? At what point do we work on our algorithms? Because I'm so much interested in the neuro-symbolic AI. Thank you.
Thank you very much for the question. This is actually a very good question and a very hard one to answer. First things first, I would say that something I think I might have gotten obsessed over the years, especially now that I'm teaching machine learning to roughly 800 students a year in my lecture hall. I got obsessed a bit with assumptions. So I think there are many assumptions, implicit assumptions that we do when we do machine learning deployment or development that should be made explicit. So that would be for me step one. What do I mean by explicit assumptions? If you are training a classifier, first assumption is IID, right? That you have a representative sample of the overall population. This assumption needs to be made transparent, and we need to find also ways of evaluating or assessing what is that the case. Towards the neuro-explicit model, you can think that what I'm doing here, right, with the causal framework is a different way of neuro-symbolic model. I call it explicit because I incorporate explicit information in the form of a causal graph into my generative model, and I enforce by design some causal consistency. So where in the process to start? I would say the earlier the better. So I think one needs to start with the data collection process and then try in the process to make assumptions explicit as possible, or at least keep track of them such that if something would go wrong afterwards, you can revise the process. So in that sense, I would argue that this is the direction I would like to go to, but how to bring that into practice, of course, there might be better speakers here, more connected to industry, but I think the problem of different works taking care of different stages in AI development in machine learning, in reality, may complicate things. So I would argue explicit assumptions, explicit decisions, and documentation, such that if things go wrong, you can go back. If you have information about the process or the application domain in which you are, the earlier you introduce that, both at the design and the evaluation, the better. But of course, how to keep that realistic, it's always an open question. I would love to have a solution for that.
Okay. Okay, thank you, Professor, for your good presentation. I really enjoy your presentation. My question is about the causability consistency. Like, I'm not sure that I heard very well what you say. Like, my question is, could you resume the causability consistency? Because my question is like, was it related about like only input data or like explaining the result of machine learning? Because you say there is three parts. First is like to fit the model, like at the end, and the second time is about focus on causability consistency. So my question is like, were you focused on, your work, was it focused on like trying about like future selection, or at the end, like only explaining the result of the model, and how is it possible if the data is not like a kind of classification
So if you're here for the Responsible AI Practical, we're going to get started in about 5 minutes. So if you don't mind coming to this front section, if you want to participate in the practical, that would be really helpful for the tutors that are going to be working with us today. Thank you. Okay, so in the interest of time, I think we're going to get started. So if you'd like to participate in the practical, like I'd said earlier, please, if you don't mind congregating in these first two sections over here so our tutors can work with you. Would it be possible to flash up the notebook so we can get started, please? I just wanted to make sure we have until 1 p.m. today. So I want to make sure everybody has the time. So if you're going to be tutoring this session, do you mind coming up to the front as well and just raising your hand so everybody knows who is going to be able to help us? So we have a few tutors here. We have Mohammed up in the front, who's going to be helping us out. Lukman over there in the back. And we'll have 2 or 3 others joining us shortly. I'll be leading this practical alongside my colleague Kendall Brogel, who will be in the back scrolling through the notebook for everybody. So hopefully we'll get this notebook shown up on the screen. Otherwise, you do have access to GitHub. And there should be a GitHub repository which contains a Colab link, which, fingers crossed, will be something we can run together. Okay? So it's very appropriate that we're following up Isabel's talk from earlier today with a responsible AI practical. So a lot of the things that Isabel was talking about we'll be able to operationalize together. Hopefully they'll be able to get that up shortly so we can kind of get started. Kendall, do you mind asking? Whenever they're ready. All right. By show of hands, does anybody have the notebook pulled up? Because if you do, then we can just get started without it on the screen and follow along together. Anybody have the notebook pulled up? All right, we have 1 hand. That's great. Love the, oh, 2. Excellent. Look at that. We're making progress. Can we get a 3rd? Anybody else? Will you guys be participating? Yeah? Okay, great. If you have the notebook, you can feel free to stay over here, or Lukman will be able to help you right from over there as well. Okay, great. So if you have the notebook pulled up, what I'll do is we'll start talking a little bit about what we're going to walk through today. So Isabel had mentioned that there are various pillars as part of the responsible AI curricula that companies are creating, but today we want to focus and dive deep into fairness. More specifically, do a better job of understanding how you can measure fairness in data sets, and then how you could fix models for potential issues of unfairness. Okay. So what I'll actually ask, this might be pretty tough to run a practical without being able to show you the notebook you're walking through. This could be really tough. Aisha? Do you mind just asking them to flash up the notebook on the screen for us? Thank you very much. All right, great. Okay, great. We've made it. Okay, so we've made it. So if you are looking at this on your screen, you're in the right place. If you're not, I can also tell you how to get here, and you can hang out with us. So again, as I was mentioning today, we're going to talk a little bit about responsible AI. We've branded it as responsible AI, but more importantly, we're only really going to talk about one aspect of responsible AI, which is basically measuring and mitigating fairness in machine learning models. Would we be able to get a scroll whenever? I know, sorry, that's a lot of asks at once, but would we be able to scroll by chance? Perfect. Excellent. So what we're going to really talk about today, we're going to focus on analyzing ProPublica's analysis of something called the Compass dataset, which is a popular dataset that captures the use of a risk assessment tool in practice. Okay, and then what we'll do is we'll use a existing library called FairLearn to mitigate unfairness that we detect in models trained on that data set. And when we mean unfairness, what do you think we mean? Does anybody have some measure or understanding of what we potentially mean by unfairness? I know Isabel covered this, but anybody have a semblance of an understanding of what it might be? A guess? There's no wrong answers. You can yell it out. I'll be able to hear you, don't worry. That's a good idea. Silence is one form of unfairness, I assume. Yeah. When we're talking about unfairness, what might unfairness stem from? What are some causes of unfairness? Okay, what is a form of a bias that exists? Gender bias, right? So you might be treated differently because of your gender. Okay. What would it look like if you were treated differently? Does anybody have an example? Right, so a lot of your opportunities might differ. In the context of a machine learning model, what that might look like is your outcome might differ. Right? So we'll be able to measure the differences in outcome as a result of your gender being different. Okay? It might also vary along race. So we call this racial bias, which is an issue the United States of America grapples with. And a lot of the data we'll look at will contain both racial and gender bias. And when we detect these biases, there needs to be a mechanism for improving and mitigating them, and we'll discuss that as well. So again, our aims just before we get started are we're going to understand bias in a specific tool and data set that exists called Compass. We're going to use logistic regression to measure biases that might result in existing risk scores, so predicted risk scores. Then we'll use an existing package, which I hope many of you will take away from today as like a way to apply and measure fairness on top of the models you end up building, called FairLearn. And then the last one is we'll measure various fairness metrics atop that. So at this point, I'm going to hand it off to Kendall, who's going to kick us off with running each of these, walk us through this notebook. But as you can see, there will be the answers directly in the notebook itself. I would recommend not running just the answer, try to do it yourself. We do have tutors who are walking around. I will also be walking around to help. And I think we have an hour and 15 minutes to work through this together. So hopefully we'll be able to get as far through as we possibly can. So I actually have the only microphone, so I'm going to have to go in the back for us to get started on this. But what I would first recommend doing is importing the data set you have. If the internet works, this will work really well. If it doesn't, I hope some of you do have it downloaded locally.
Okay, so just a little bit of background on the data, which we're going to go ahead and analyze and go through, but just so that we all have a good understanding. Like Umang said, we're looking at ProPublica's analysis of Compass's model. And the important thing to note here is that what they had access to was the data from over 10,000 criminal defendants within this county in Florida over 2 years. And they had the outputs of the model, which were the risk scores assigned to defendants. They did not have the model itself, so they didn't have the information as to how it was trained. So they had to, this is where they performed their own analysis to model how they got these outputs. So each Compass produces 3 scores for each person. One is the risk of recidivism, the second is risk of violence, and the third is risk of failure to appear. And these are scored 1 through 10. So then within that, 10 is the highest. So within that, 1 through 4 meant that they were labeled low risk. 5 through 7 was medium, and 8 through 10 was high. Just so we have an understanding of the data we're looking at. And then, like Umang said, the data included things like age, gender, race, degrees, priors, etc. So it's important that we have a good understanding of this data before we get into it. So the first thing, which has already, the code's already written, so you can just run this cell, hopefully it works, is to check your data. So this should, I'm not sure it's going to run up here, but we're going to look at the shape of the data, and print the head, so the first 5 rows. And then these notes are what we just went over. The important thing is the output, which is a numeric score 1 to 10. And just to make sure we're clear, recidivism here is reoffending after being released from prison. So they're trying to predict who, if they're granted parole, will reoffend and end up back in prison. So essentially what they found was that, for one, it was largely unsuccessful. It was not actually very accurate. And B, the summation was that it is a racist model. They found that it was significantly more likely to predict black offenders as more likely to reoffend. But we're going to figure that out for ourselves. So we're going to go through their exact analysis and do it ourselves. So here we can run this cell to inspect the data, like I said. So we have all of our variables and the descriptions so that we have an understanding of that. And then this is our first place where I'm going to have you guys try to write the code yourselves. So I'm going to plot the distribution of age, race, and sex within the imported data. And this is where the answers here. I'll close that. But so hopefully you guys will be able to do it yourselves. Just give you like 5 minutes. And if not, so you can keep up, you can use the answer cell. So it is 11:46, so I'll give you guys till about 50. And all the tutors are wandering around if you have any questions.
To be clear, this will be run over different plots. It's not just a single plot. I mean, we could do that, but that might be non-trivial.
Bonjour à tous. Les participants en français, s'il vous plaît. Ceux qui comprennent seulement le français, levez vos mains et puis je viendrai vers vous pour qu'on puisse échanger. Ceux qui parlent français. Ok. Descends. Merci beaucoup.
Okay, so just to make sure that we're all on the same page, I want to reiterate what this model is. So the COMPASS model was used by a county in Florida, so a state in the US, and what they were trying to do was predict whether criminals within their justice system were going to reoffend if they released them from prison, essentially to make judges' jobs easier. Judges that will sit there and look at all the information, similar to what this model gets, and say, I think that they are very likely, so we should not release them. Or they might be likely, or they're not likely at all. So this is a judge's job to do themselves. They look at this data, they analyze it. And what COMPASS was attempting to do was to essentially automate this. So to create, using historic data for over 10,000 criminals within their justice system in 2 years, looking at the data of who reoffended and who didn't. So they had all of the variables that we're talking about. They looked at them and they created a model that based off of these things that they're just looking at, like the 2-year recidivism rate, the time in jail, et cetera, their gender, age, race, how likely were they? And they implemented this model for many years, at least 2, 2013, 2014, and judges were using this as a tool. So instead of sitting there and thinking about it, they were using this model to decide if people should be released from prison or not. And then ProPublica, which is an investigative journalist company, performed an analysis based off of just the data of the offenders that was being used in this model and the scores that they were provided, which they had to request through a public forum. And they wrote this article, which is linked at the top of the notebook. It's very interesting, and essentially concluded that not only was this model not fair, but it was racist. And it illustrated the point that is very, very, very important within all of AI, responsible AI, that your model can only be as good as your data. And so when using this historic data, there was a very clear tone of discrimination, particularly towards people of color. So they essentially had performed all of these analysis that we're going to then do to quantify how their predictions of people who are going to recidivate were discriminatory and not fair, which is something that this here, the risk is incredibly high because we're talking about people being released from prison or not. But it's widely applicable to all sorts of models anyway. So I'm not sure if you guys have had enough time. Maybe give me a thumbs up. Okay, we're good. We're going to keep going then. So something that's always important to do is we're going to pre-process our data to make sure that it is correctly formatted, et cetera, to be using in our analysis. So this cell is already done, so you can go ahead and run it. Hopefully that works. Where we're going to keep a certain set of variables that are important to what we're looking at. So here it's your ID, your age, what degree you have, your score, your gender, your priors, your decile score. So the goal here is we don't need to spend a lot of time doing it ourselves, but it's important to get a feel for the variables and the structure of the data. Another point here that we want to make sure we note is that the flag for recidivism is -1. So that means that they did recidivate, they did reoffend. So your output should look something like this. We have the shape of our data, and then we have the top 5 rows of the specific variables that we want to look at that's important to our analysis. And then along with -1, the charge is, which is ordinary offenses. Okay. So the next cell you can also go ahead and run. We've done it for you. And this is essentially just going to screen the data so that we have it within the parameters we're looking at. So we only included people that had recidivated within 2 years or had at least 2 years outside of a correctional facility. So this is essentially baked into the data that was imported from the GitHub data that you guys should have run beforehand with the data name. Anyway, so next, hopefully everyone is up to here. We're going to do our second action item, which is to check the dimensions, meaning the variables and observations of of our data that has been pre-processed. So we now have it down to the variables we want within the parameters we want. Again, your work can go in this cell and the answers are there. If you need any help, please raise your hand. And I think we will go with about 5 minutes, so at 12, we will check back in.
If you're just joining us, welcome to the Responsible AI Prac. If you'd like to participate, please sit in one of these first 3 rows or at the first few rows of the second set of chairs. If you go to the GitHub repository for Indaba 2024, you'll be able to find a collab notebook. That is the one that we have popped up over here on the screen. We're currently through 2 of 17 to-dos. We have an hour to get through the rest. If you're just joining, once you've pulled up your practical, please run the answer key for the first 2 to-dos, and then you'll be able to get started right away. Thanks.
did not finish, you can go ahead and run the answer cell so you can keep up. Don't want anyone to fall behind. So here, the important thing to note is that we're looking at the difference in our data before and after. We are only looking at this part that is of most importance to us. So only the variables we want within the metrics that we want, parameters. So you can see that the data before and after filtering has been reduced. The next step, we're going right into the next to do, but this is essentially going to be, you can run this cell that is just converting it to a numeric value. That's been written for you. But then we're going to essentially do what we did the first time again. So hopefully this will be straightforward for you guys. But you're going to replot these things after the data's been processed, with the data you just processed. And we're going to plot the distribution of age, race, and sex compared to before and after it was pre-processed. So give you guys, hopefully this will be straightforward because you should be able to reuse some of your code. So I'll give you like 4 minutes, 12:05-ish. Again, make sure you raise your hand if you have any questions. Okay, so we're going to keep going and take a look at the results from this. Here, it's important for us to look at is not just the summation of how many data points we lost, but it's also important to look within that at the groups of people we lost, because it's significant if, when we reduced our data within our parameters, if it was very disproportionately affecting one group of people, because that's therefore going to influence our results. And we need to make sure that our results are fair regardless of, here we're looking at race, also looking at gender, etc. So hopefully your work looks something like this. If not, you can see the results up here. Next, this bit is a little bit trickier, so I'll walk through it, but we're going to generate a crosstab summarizing the number of observations by race and sex. So essentially, what we're looking to do is we're going to use a pivot table, looking at the IDs, so So, instead of their name, each offender has an ID, race, and sex. So that our output will give us an idea of the distribution of women and men within each racial category. So hopefully that is enough to get you guys going. Use a pivot table and those factors. Our answer, use the lambda function if that's a hint. But if not, please raise your hands and I'll give you guys another 5 or so minutes, maybe a little less. that was enough time. Don't mean to rush everyone. We're just a little short on time with the delay. But next, if you didn't get a chance to look at the crosshead answer first, we'll look at this. So you can see the female-male ratio broken down within each race. So you can see that the largest group is the African American group. Next, we're going to get to our exploratory analysis. Hopefully you guys all have a good sense of the data, its breakdown within each of these categories we've looked at. But now we're really going to focus on the main variable that we've been talking about, which is the recidivism score. In this case, it is labeled as the decile score, so that's important. That is the variable name within this data set. It's written here under exploratory analysis. But we're going to focus on looking at this. So the first thing we're going to do is plot the decile score, which is the recidivism score, by gender. So we're going to have one plot for male and one plot for female. And we're going to take a look at the scores. So then we can analyze how the distributions differ between the genders. So you can go ahead and run this cell. Take a look at the code if you have a chance. But this is what it should look like. Then this is going to lead us to the 2 to 5, which hopefully will be straightforward because what you're going to do is do the exact same thing that we just did for gender with race. So specifically looking at the black and white defendants. So once again, there will be two plots, one for black ID numbers and the other for white. So hopefully you can repurpose the code above. Take a look at that. And we're going to look at the recidivism scores, which is, again, here it's labeled as decile score for the races. I'll give you guys a couple minutes. Okay, I know that wasn't a ton of time, but hopefully it was pretty straightforward, like I said. So to reiterate, when we're looking at the female and male scores, the distribution is pretty similar. It has a similar shape, however, you can conclude that the female defendants have lower decile scores, so they're less likely to reoffend. But it's not particularly different, the two plots. But when we take a look at our results for the race, you can see that there is a very, very distinctive difference in the scoring distribution between white and black defendants. So hopefully this all leads us to thinking about what this means and how the distribution of black defendants is not particularly even based off of how likely they were, their prediction versus their actual, right? So next, we're going to move on to the sixth to do, which is we're going to summarize the difference that we're looking at here of decile scores for black defendants and white defendants. Just write a quick sentence. We don't have a ton of time, like I said, but just to make sure that we're thinking critically about how these graphs differ.
couple seconds to write down those sentences, and then our tutors will go around and we'll have 2 or 3 people share. Okay? So you should be able to run all the way up to 2 to 6 if you're just joining us. And then you want to analyze these last 2 plots. So if we scroll up a little bit, you'll be able to see these 2 plots, which summarize our, in our data set, what decile score we've assigned to both white and black defendants who are currently incarcerated, but we want to understand their likelihood to reoffend before we remove them from jail.
Pour ceux qui parlent en français, ce qu'on va faire maintenant, c'est analyser deux graphiques. On a 2 groupes, le groupe des blancs, on dira ça comme ça, et celui des noirs. Alors on va donc voir comment est-ce que, avec les données, il y a une certaine discrimination. Et si on utilise ces données sans pour autant étudier les différents biais, on se retrouve en train de créer une IA qui est irresponsable du workshop. Alors, ce qu'on va faire maintenant.
For the sake of time, we're going to slightly skedaddle along. Does anybody want to tell me what they observe on this particular plot? We're gonna wait until someone has something that they want to say. So, Kendall, if you don't mind scrolling up a little bit so we can see the 2 plots. Great. So, we'll wait till someone wants to say something about this plot. Any ideas on what you observe? We asked you to write 3 sentences. Okay, right up here. Great. We're going to do one in English, and then we're going to do one in French as well. So hopefully we'll be able to have 2 different takes.
So for the black defendants, we can see that from 8 to 10, which is the I decile score and I probability that they would reoffend. For the black defendants, it is high. Why? Almost 0.1. Why for the white defendants, like the probability is low, it's like tipping low. Why for also the white defendants, we can see that from 2, the probability that they will not reoffend is high. Why for the black is still so the black defendants have a high probability that they will reoffend from 8 to 10. Why the white defendants have a probability they will not reoffend from 2 to 4.
No, that's incredible. So just to reiterate, if you are a black defendant, your likelihood of reoffense, in some sense, is potentially equal across all cases. But if you're white, what we notice is that there's some sort of a distribution, a more pronounced distribution, which suggests that you're less likely to reoffend, almost by nearly 10%. The question is that this might be what your data set looks like, but is this the type of data set we want to train a model on? Okay. And that's going to be the more important question that we're going to ask going forward. Okay. I'm going to ask if there's someone who's a French speaker who wants to share their thoughts. Okay, great.
Ce que j'observe, c'est que pour les noirs, la distribution elle est presque constante en fonction du score, tandis que pour les blancs, on voit une sorte de décroissance, une sorte, ce qui peut expliquer que chez les noirs, on a constamment le score qui varie toujours en moyenne de 0,10, ce qui est vraiment différent pour les blancs. On a presque l'impression qu'on connaît déjà le score qu'on va attribuer aux noirs, tandis que pour les blancs, il y a vraiment une bonne variabilité et la distribution elle est plutôt décroissante.
Bon, oui, ici on voit la distribution, c'est pour les femmes. Les femmes, ils sont jugées. Ça, c'est basé sur News, donc ici. Il y a un site là où tu vois les photos qu'une femme a été classée parce que les femmes, les hommes sont plus vieux que les femmes. Donc là, il y a une photo qui démontre que voilà, la femme elle est plus dangereuse que l'homme, elle est récidive, et le système là pour ça. Parce que ce qu'elle a montré là, il y a un grand pourcentage d'hommes qui sont récidifs. Donc c'est ça OK?
All right. Okay, so I think we're making progress. We're through our sixth to-do. Let's move on to to-do number 7, Kendall. If you want to walk everybody through that, and then we'll move on to 8.
Great job, everyone. Hope everyone is keeping up and you're starting to see what we're getting at here. But next, if you remember at the beginning how I mentioned that the official analysis grouped these scores into 3 categories: low, medium, and high risk. So 1 through 4 was low, 5 through 7 was medium, and 8 through 10 is high. So what we're going to do is repeat our to-do that we just did, the code. So it was 5. But this time, instead of it being the decile scores 0 to 10, we're going to group them into those 3 risk categories. So you should have 3 bars within your plots. Again, you will have 2 graphs, one for black defendants, one for white. So instead of having 10, like we do here, you should have 3 labeled low, medium, and high. So go ahead, I'll give you guys a few minutes for that. The variable also, you can read it in the instructions, but it's labeled score text, is the variable name for the low, medium, high. Okay, I know that was very short, but for the interest of time, since this is very similar to what we just did, so you've got an idea of the code, you can go ahead and run the answer if you haven't, the answer cell if you haven't gotten to it, and we'll just take a look up here. So I think that this makes it a bit clearer as well when we group our decile scores, makes the difference very clear between black and white defendants. How many were assigned low risk for white versus black? It's a very prominent difference. We're fairly above 40% here and almost 70 here. All right, so this is where we can really start discussing what we've been looking at, right, which is the bias in this compass algorithm. So in very general terms, what they concluded is that there was bias, racial bias, right? But we have to look at how the risk scores vary. That's a very broad statement. We have to have information to back it up, and we need to do further analysis to look into this. So we're going to look into the extent with which the risk labels assigned to defendants match up with what they actually were. So the observed versus actual. So we're going to approximately reproduce the analysis that was done by ProPublica here. So this is where we're getting into the good stuff. We're going to talk about logistic regression here. So the ProPublica chose to use a logistic regression model to analyze the variation of the risk scores. So we're going to prepare the data by one-hot encoding the categorical variables. So So this means that some of our data, which was not numeric, we want it to be numeric for this logistic regression. So one hot encoding is going to turn this into binary data where it's either yes or no for each of the potential categories. So if we have low, medium, and high risk, it's essentially going to break that column into three, where there will be a 0 for 2 of them, let's say low and medium, and a 1 for high, instead of using the words low, medium, or high, so that our model can process the numeric data. So go ahead and run that cell. Here we're looking at the data type specifically, or we print out our data types so that we can see which variables we need to address. And then we're going to use a for loop to iterate through and convert these. So you guys can just go ahead and run these cells. I know that was a bit rushed over, but I hope that everyone's keeping up. And then here, we're going to set up our logistic regression with our one-hot encoding. Just keep running these. And then we are going to take a look at the top 5 rows of our data to make sure that it is all numeric. All right, and then we're going to begin to estimate our logistic regression model. So here we are specifying the specific model that we're going to use, and so we're going to, here we're going to select the variables that we want to use in our data. Again, the ones that we have all made numeric that are most important, that we're focusing on, that are relevant to this. And then here we're setting our response, which is our output, equal to the binary, the score binary. So that's our recidivism score. And then we're going to fit the model. And once we do that, we're going to print the model summary. So we want to look at the results of our regression. So I'll give you guys a minute to just take a look and see if you can find some meaning in here, looking specifically at all of this. It's a lot of numbers. Just look through it and see what you think. Okay. Hopefully that was enough time for everyone to look, but now we're going to interpret these estimates, right? So we've already done this, we've read through them, but what we want to do to interpret these estimates, something that's helpful, is calculating the odds ratio, which means that we're going to take the exponential of the coefficients of each of these variables that we've looked at, that we included in our model. So for example, if we're taking the exponential of the coefficient for sex underscore female, which is the name of our variable for females here, our beta here is 0.2213. So if we use that, it's going to return the odds of the score taking the value high for a female relative to male. So what this means is that we want to look at the odds of someone who is labeled female in our model being labeled as high risk compared to a male. So here for to do 8, we're going to try to calculate the odds ratio. And you might need to look at the answer for this one, but hopefully you can all figure it out or ask a question, but it's a function within NumPy. So I'll give you just a couple minutes because it should just be one line of code. But I know that might be a little, we kind of sped through, so. Okay, so here's the answer. We can just look at it together since it's so short, but we're using np.exp, right? And we're going to put in the beta, so the coefficient of female that we talked about earlier, right? And it gives us a result of 1.2476, etc. So what this means in words is that the odds that our COMPASS model labeled a defendant as high risk of recidivism is 1.25 times greater for a female than a male, right? So you could repeat this for any of the coefficients and specifically look at the comparison between these two, whatever two variables you're interested in looking at. So we're going to do it again, just 30 seconds, calculate the odds ratio for all of the coefficients, minute. Okay. Again, if you haven't gotten the chance to do it all, we can go ahead and run the answer cell, and we'll take a look together. Here we have the odds ratio for each of the variables. So what we're next to do is going to be, we're going to take a look through this and think about what is the reference category for each variable. You know, for females, you're referencing this to males. What is the comparison that you're looking for here? So we have this sentence structure here, which is a person with a value of blank on variable blank is blank times more likely to be labeled high risk compared to a person of blank on variable blank. Here's an example. So for our number 10, we're going to go ahead and summarize the odds associated with the age category variable. Just 2 sentences. This should be super quick. And then we can move on. All right, we are going to go ahead and move on. So now we're going to be looking at the predictive accuracy, which means that in terms of the ProPublica, the analysis here, they focused on the predictive accuracy of the COMPASS algorithm. So how good was this algorithm at predicting the actual results? So here, predictive accuracy is referring to the concordance between a person's recidivism and the label assigned to that person by the algorithm.
So was the label accurate? For instance, how often did Compass predict that a person was high risk and that person did in fact recidivate within 2 years? Was it accurate? Did our prediction match our actual? Here we have a 2x2 table that we're going to work through where we have someone who is labeled as high risk and did not recidivate. Someone who was labeled as high risk and did recidivate. Same thing. They were low risk and they did not recidivate. Low risk and they did. So ProPublica, what they did is they reported A and D. So here A is they were labeled high risk and they did not recidivate, and D is labeled low risk and did recidivate. They reported these separately for black and white defendants because it's important to note that this model being accurate and what specific scenario you're looking at is very different, because if you're looking at people who were labeled high risk and did recidivate, that is a different accurate response than someone who was not labeled and did not reoffend. So we want to make sure that we're looking at the breakdown between the races here. Here we had a little writing bit, but in the interest of time, we'll just go ahead and move on here. We'll talk about it. So he said, ProPublica used different data set to calculate the predictive accuracy of Compass. So in this section, we're going to use data frame underscore logistic, the data that we've already assigned, pre-processed above. So the numbers we calculate below are not going to exactly match ProPublica's, but they'll be very similar. But we're going to create a crosstab right here. It's already done, so we can run this cell. That's denoting recidivism within 2 years, and then the binary score. So you can run this and take a look. And when we're looking at our A and D, we want to note that those are false positives versus false negatives, right? So false positive means that, well, you were predicted as positive. So in this case, you were predicted to reoffend. You didn't. Others, you were predicted to not reoffend, and you did. Okay. So then we're going to get to do 12, which is we're going to look at the crosstab we made together right above, and you're going to input the number of true positives, false positive, true negatives, and false negatives. So think about, this means that was the prediction from Compass true or false? If it's a false positive, that means that they thought it was positive, but it wasn't. If it's a true positive, it means they thought it was positive, and it was. I guess you guys can kind of see the answers, but that's okay. We'll do this quickly. I'll give you like 30 seconds. All right. So here you can see the answers. Hopefully this is what you guys got. If not, you can fix it. But here we have 934. That was our false positive, and this was our true positive. And then we have our true negative and false negative. So next we're going to calculate something called the false positive rate. So the rate of false positives. Hopefully that's self-explanatory. But we want to see how often was this model predicting that someone was going to recidivate and they were not. That's super important. That's essentially the end-all be-all of what we want to look at, is if this model is predicting people that they should not be released from jail when they really should be. So this is done by taking the false positive, the count we just put up here, divided by the false positive plus true negative. So I'll give you guys a minute to do this. You can look at these results on the screen if you didn't have a chance to finish filling it out to make sure that you have the correct values when you're calculating it here. So I'll give you about 30 seconds. And again, please raise your hand if you have any questions. I know it gets a little confusing with the false, true, etc. So I went ahead and put up the answer on the screen so we can look at it together. But here, we have our variable for false positive and true negative, and we use those just like the equation that we have above, where our false positive is abbreviated to FP also. And then we multiply it by 100 so that we have a percentage. So here our false positive rate is about 29%. So that means 29% predicted as positive or not. So now we're going to do the same thing with the false negative rate, and I'll just, since it's the same thing, we can go ahead and run the answer cell to keep moving. But it's the same exact thing, except for this is going to be the false negative divided by the false negative plus true positive. And here this was about 39%. So you can look at the difference between the false positive rate and the false negative rate. It's almost 10% different, which is pretty significant. Now we're going to look specifically at how these false positive and false negative rates vary by gender. So not just race, but how this is affecting gender. So we're going to create a crosstab here, like we've done a few times, of the score binary and is recidivate for female defendants and calculate the false positive and false negative rates, specifically for females. I'll give you guys like 30 seconds, and then we'll pull up the answer. So hopefully you guys are getting the hang of creating these crosstabs. We'll take a look at the code here. And this was our result here. So we're looking, again, it's the same 2 by 2. That's looking at whether they recidivated or not, and their prediction, but this time only for the female defendants. So then, once again, this cell is, you can just go ahead and run, but we have the false positive rate and the false negative rate, specifically for female. So if you remember what they were above, now we can see the difference in how our model was predicting outputs based off of gender. So is the output the same regardless of if you're female or not, or is it different? So here we can see that our false positive rate was pretty similar, and so was our false negative rate. It was about 2% different. So now we're going to do the exact same thing for males, and this should be super quick. Hopefully, if not, we'll run the answer cell, but go ahead and do the same exact thing for male defendants. So calculate the false positive and false negative rates. should have been able to repurpose your code and just changing the variable from female to male. And then we can compare our female and male false positive versus false negative rates. And if you remember what they were above, it's pretty similar. It's a little bit lower than false negative rate. So here we're actually going to go ahead and calculate how the false positive and false negative rates vary by race. So calculate the false positive rate and false negative rate for white defendants. Again, we're going to do the same exact thing, but instead of looking at gender, we're going to look at race specifically. We're going to look at these rates for white defendants. All right. So if we take a look at our answer here, it's the same code as above, and we're just using race Caucasian here. And then when we look specifically at our false positive versus false negative rates, we can see that our false positive rate is considerably lower than it was for the overall, and our false negative rate was 50%, which is pretty high. That means that 50% of the time we were predicting that our defendants were not going to reoffend, and they did. So then we're going to go ahead and do the same thing for our black defendants so we can compare the two. And this is our last to do, so we're almost done. But this should be super quick, and then we can talk about it. Again, just use the same code. All right. Here, when we take a look at our results, our false positive rate is 41%. So that's 11% higher than it was for the overall. And our false negative rate is 29%. So that is 20% lower than it was for white defendants, our false negative rate. Right, so what this means is, hopefully you guys are starting to see how this comes together, that for white defendants, this model was much more likely to make errors in predicting the defendants were not going to reoffend and therefore release them from prison than they were the other way around, and they were for black defendants. They were much more likely for black defendants to predict that they are going to reoffend and they should be high risk. So it's important here. Was our last to do. So thank you guys for staying along every step. I hope that if you have a chance, you'll go through the second part of this lab because it's really interesting. It uses a package called Fair Learn, hopefully on your own. But to to go through the importance of this, right, we're thinking about that not all accuracy and errors are created equal, right? It's important to note the distributions within certain protected attributes, and also specifically our false positive, false negatives. So Uwan can go ahead and wrap it up.
Awesome. So thank you for that, Kendall, for walking us through that. Especially all the way from the back when you can't see any of our faces. So thank you for that. I think we should give her a round of applause for doing that. So just to quickly recap what we did here, what we did is we were given a data set of information about individuals who were in jail, and more importantly, we wanted to assess whether they would reoffend were we to release them. In our data set, we had access to two things. We had access to a true label, but we also had access to decile scores that ProPublica, an NGO, an investigative journalist group, actually reported and released out into the world. So what we did is we first took ProPublica's scores, we looked through their decile scores, came up with a conclusion on if they treat black and white defendants differently. Once we saw that, we realized it actually might be important to approximate the model that ProPublica used, because we don't have access to it, it's proprietary. So what we'll do is we will use a logistic regression classifier to approximate it, and we notice that even when we try training alone afterwards, we end up noticing unfairness as well. So unfortunately, due to time constraints, we're not able to keep going through this notebook, but the rest of the notebook starts to address how do we minimize and equalize our model performance across these categories. What kind of fair world do we want to live in? Do we want to live in a fair world where the false positive rate is equalized across two different subgroups, across men and women, across black and white defendants? How would you go about doing something like that? The beautiful thing is that the Fair Learn package abstracts away some of the theory that's required, but in the end, you're still able to use that. So with that, we'll give you about 5 minutes back. If you have any questions, the tutors are around. They've been super helpful with going through this practical with you guys. And Kendall and I will also be here. But thank you very much, and we'll see you around Indaba. Thank you.
Donc moi, je vais récapituler en français. Dès le début du travail, on a pris un dataset sur comment est-ce qu'on pénalisait les individus lorsqu'ils se présentaient à la cour. On a eu les données sur la vraie décision, c'est-à-dire la sentence finale, mais aussi sur si les individus pénalisés étaient coupables ou non. Comme caractéristique sur les individus, on a leur âge, leur sexe et encore leur race, on dira blanc ou encore noir. Pour étudier s'il y a des biais ou non, on a comparé les décisions par rapport au genre, par rapport à l'âge et surtout par rapport à la race. On se rend compte que, précisément pour ce qui est de la race, il y avait beaucoup plus de chances qu'on prédise pour un blanc qu'il est non coupable, plutôt coupable, tandis que pour les noirs, c'est beaucoup plus probable qu'il soit condamné coupable lorsqu'il est non coupable. C'est donc des biais qu'il faut toujours identifier dans les données avant de les utiliser. Sinon, même les modèles qu'on va monter seront biaisés. Ils vont apprendre de ces biais-là et au final, ils vont perpétuer les différentes erreurs qu'on a commises dans le passé. Donc, ce qu'on va faire dans la deuxième partie, qui est dans le notebook, c'est maintenant voir comment mitiger ces biais-là, les minimiser. Dans la première partie, on a vu comment identifier. Là, vous pouvez parcourir le notebook. Si vous avez des questions, vraiment, n'hésitez pas. Don't hesitate, thank you.
Thank you.
guys. I think now we can join the launch.
good afternoon. Okay, now we are starting our afternoon session. So today we have our speaker. It is my pleasure to introduce Germa, who is Indaba friends, previously was also program team. Yeah, and this is speaker. So Germa is a principal research scientist and manager at Microsoft AI for Good Research Lab, which aim to develop AI solutions for critical problems across sectors, including agriculture, healthcare, biodiversity, etc. Prior to that, he was a staff research scientist at IBM Research Africa. He worked in detecting and characterizing systematic deviation in data and machine learning model. Also, Germa was postdoc at Oxford University, right? Yeah, and he holds PhD at Queen Mary University of London. Let's put our hand together to welcome Germa. Yeah. So much.
Good afternoon, everyone. Good afternoon. How was lunch? Yeah, I didn't have one because I just landed this morning, and Aisha and Raul asked me to reschedule and give this presentation now. So if you see some discrepancies, because I don't have lunch and coffee. Aisha would control my slide presentation from there. I heard the signal is poor. So my name is Grimao. Very, very excited to be here, and currently based in Nairobi at Microsoft AI for Good Lab. Some of you may be a little bit aware of the lab, as we try to work on critical challenges, at least in our opinion, that matters at the moment. Definitely, this is not the first time at Indaba, but when we think about AI, of course, that's why most of us are here. Definitely, it has a great potential to help address problems, but the discussion lately is not really the development of the solution, the kind of model we employ. Rather, it is how could we make really practical solution out of it. And my presentation today will be focus on those things. Aisha, next slide. We always talk about AI, but usually, audio video system is more challenging one. So a disclaimer, I have been across different places, originally from Ethiopia, of course, currently living in Kenya, but my career trajectory in AI started in 2011 when I did my master's internship in Portugal. Then I spent a few more years in Europe before I came back to Africa, where I worked for IBM Research and now with at Microsoft AI for Good. So my perspective on AI and how we should able to use it are, shaped by those experiences, problem domains, and amazing team of researchers I have been working with. Next. As I said, AI for Good Lab is not a big lab, a bit philanthropic lab at Microsoft. The bigger team sits in Seattle, but we have also a presence in other places. But the research team in Africa sits in Nairobi. Some of my colleagues are here, Jules and Akram. what makes us different is it is a research team, but try to use AI for critical problems of our time, whether it is climate change, sustainability, conservation, or disinformation. Next. So what's my objective today? As I said, trying to discuss with you, share some of the experience I learned across these years on three key pillars of AI for practical impact. One is it is solution development. Two, you know more than I do that having a data model by itself and having 90% accuracy is nothing if we don't implement it on the ground. That implementation really requires whether that model, that solution you developed is actually trustworthy, which means is the agronomist or the clinician or the policymaker going to use your solution. The third is we could always use solutions to get things done, but what are we trying to really achieve at the end of the day? Is that impactful? And my conversation would focus around these three pillars, but most importantly on African use cases, because this is deep learning in Indaba, and lately we are heavily focused on as well working on problems in Africa. So why Africa? Why Indaba? You know, it's a great opportunity, a great place to be at this time because of one, a promising potential for AI. You see a number of success stories across different communities that start from Indaba, different startups that are born from the continent, Lelapa AI, our recent success story. But also, we have a bunch of big tech companies focusing and investing in the continent now. So this is a great opportunity. And if we consider some of the challenges we have in the continent, but of course this is promising. But at the same time, in Africa, we have also a different challenge. If we consider climate change and sustainability, the challenge we have is much more, disproportionate compared to the cause coming from the continent. If you consider electricity or how much percentage of the population in the continent access early warning system for this changing frequent climate disaster is still a very tricky problem. And if I show you a few examples, we are very common to see such problems and challenges in the continent, starting from flood in border town between Ethiopia and Kenya. We have also disasters in South Africa. And Aisha, next. Tornadoes in South Africa, it's a very recent example. And if you see, we have flood in Libya, Morocco, earthquake rain is there, but also flood in Nigeria if you go to the next example. So, the disasters are happening very frequently, throughout the continent, whether it's north, south, east, and west. And of course, when you see such a problem, it asks how could we really, potentially cope up with, such a problem challenge. And probably most of us agree by now that we cannot just keep doing things the way we have been doing. We need to use new technologies, cutting edge techniques to potentially cope up with these growing challenges, and definitely AI will provide that capability if we use it in the right way. So, as I said, the development of AI solution is not really the challenging or the most difficult part of the pipeline nowadays, actually. So let me ask a question. How many of you are currently developing an AI solution for a particular problem? Can you raise your hand? How many of you are currently developing an AI solution for a particular problem? Perfect. Good. How many of you are using clean data, or let me reverse the question. How many of you have ideal data to work on your problem? Ideal data, clean data, perfect data, if there is such a thing? No. How many of you are currently involving domain expert in that problem domain? I see 1, 2, 3. Yeah, that's encouraging. But you know that this is just trying to understand problem, probably easier to formulate, but the practicality of it, the data challenge is more severe compared to what you ideally expect. But at the end of the day, if you want to make an impact, you also need to have the domain expert into it. And of course, I went through all the process. I even sometimes, I think in my PhD, I collected my own data set. But you can't do research with that, but you know, for practical implementation, that means nothing. And that's what I focus usually on data, right? Using model X, model Y, model Z is not really, especially nowadays when you have Copilot and other product, writing a code, you know, plugging a model is not difficult, but is it trustworthy? Probably the responsible AI conversation, I guess this morning, may touch down a bit, but usually it's very clear that it's easy to do research. It is easy to publish a paper sometimes, but we need to make sure that solutions are trustworthy. What does it mean? If solutions are trustworthy, they may affect a certain segment of population, you know, in adverse way. Or sometimes they may not work for a certain segment of population compared to the other. One thing we recently came across is if you consider, for example, work in geospatial machine learning and land cover maps, the context in Africa is different. So most of the global models out there, you know, developed, trained with different models that is not very reflective of the context in Africa. Usually we found them struggling to work better in African context. This is a COVID example, probably. I shared it a few more times when I have a presentation. When COVID hits, of course, many researchers try to understand or predict it from different modalities. And one study tried to understand, I think, evaluate close to 300 papers that tried to detect COVID from medical images. And the conclusion was like, none of them were clinically fit. So I know we are here, students, researchers, and usually trustworthiness is really key, because if it doesn't make an impact on the ground, then we cannot afford to, you know, waste our resources, especially in African context where we don't have much opportunity. So if we go into details, of course, when we say trustworthiness, it has a different dimensions, whether it is robustness to, you know, out of distributions, adversarial attacks, the data is private, sensitive materials are locked, and reliability, and so on. I will not go much into detail, but I will highlight what I usually say about data. If we go to the next slide, Aisha. AI pipeline is often data, model, output, and that output is supposed to be insightful for decision makers, right? But my argument often is data is a very critical component. That's why when I ask that question, how many of you have a perfect data? There is no such perfect data. After all, it's just a snapshot of the reality. But the more we spend time on the data, the better we probably will come up with the right solution that reflect that context. Because as the saying goes on, you know, garbage in is garbage out. And again, usually, of course, I do see in research that as long as you have data from this company or this university, we just download and work on it. But we need to really understand a lot in it, because deviations in data could inform a lot of information about the data, whether it's representation, whether it's the quality of annotation, whether it's a disagreement, whether it is adversarial, and so on. So in the three dimensions we have discussed, we already agreed that developing an AI solution is easier. What's more challenging is making sure it is trustworthy to be used by the actual user at the end of the day, right? By that, one very significant dimension of trustworthiness is the data quality, because data will inform a lot of things about the reality and the type of model you pick. The type of performance evaluation metric you employ should be aware of the limitation you have in the data. And always you have limitation in any data set you are working on. Something I want to spend more time today with the title of the talk is Impact and African Context. With that, I will just highlight a few projects we are working on in Africa. Depending if you have any questions, please, you can interrupt me, but these are projects that are African by nature, but their collaboration is global, but they always start with the problem. The problem set by not us, AI researchers, but the people working on the ground. One project we have been working, in fact, Gilles is the lead researcher, is understanding food and water security trajectory in Kenya. So I really like this project because it often tells the complex nature of problems on the ground. When you think about food security, the solution is always produce more, right? If you want to have more food, you produce more. One way of producing more is irrigation. But this problem with the Nature Conservancy and CITRAD is that if you use irrigation, which means you use natural water resource in that area in unmanaged way, in a long term, you may have water security problem, right? You can use water, get more food short term, but long term, you will have water security problem. That means you will have community conflicts. And this work was trying to understand how, in a specific period of time, agriculture expanded in this area, and what's like the estimate of water consumption over the years. This question came from CITRAD and the Nature Conservancy because they want to know the reality. And this project was designed to inform them how agriculture is expanded over the years and accordingly the proportion of water usage in this area. If you go to the next slide, Aisha, what you see is a very different problem. When you see climate change, it's not only people that are affected, but also animals. And the animal ecosystem is important everywhere, but also in typical African economies like Kenya, South Africa, because of conservation, sustainability is more critical. One project we are working with Kenya Wildlife Trust is trying to understand the risk profile of people living around Masai Mara, which is a famous conservatory, as you know. Because of climate change and sustainability, people are moving closer to the national park, and then you have a conflict. And what Akram, I don't know if he is around, is working in this project is trying to build from satellite imagery the risk profile so that the domain experts like Kenya Wildlife Trust could know which people are risky so that they could put fence, relocate some people, or come up with more informed intervention. Another project is land cover maps, right? And the kind of problem we are trying to address in the third project is, how many of you know the 2019 EU anti-deforestation law? One hand? That's where the problem came in, right? The EU anti-deforestation law says, of course, we can buy tea, coffee, and other agriculture products from Africa. But you need to make sure that that coffee or tea product doesn't come from a deforested land. So this is a great effort to discourage deforestation, but the reality in Africa is most of the farmers are small-scale farmers. Most of the producers of tea and coffee are small-scale farmers. So you have a compliance request from EU, you have like 70–80% small-scale farmers who has no technical resource to prove that, look, you can go back 10 years and you could see that this coffee was not coming from a deforested land. That is where we step in. With a collaboration with Kenya Space Agency and Clark, we try to build a high-resolution land cover map in the first place, which may have different downstream tasks. It's not just current problem. We could go 80, 90 years in the past and also understand environmental challenges in Namibia. But again, what you have been seeing are different projects focused on problems that are really important not to the researchers, but the people on the ground. Whether it is Kenya Wildlife Trust, because they have real issue with people and animal conflicting. Whether the Nature Conservancy, who knows that agriculture land is expanding uncontrollably, which may even sometimes catastrophic for long-term sustainability, and so on. But I think usually I try to mention one common thing across these projects. I didn't talk about what kind of deep learning model we employ from satellite imagery, semantic segmentation, and so on. The point of this conversation is not the model, rather how you define the problem, who you are working with. And by now, I hope you understand that all the projects have a domain expert collaborators who knows the problem better than we do. And the more you work with these collaborators, people who know the problem better, there is a higher chance you may, at the end of the day, build a solution that's actually trustworthy and potentially impactful. We have time. So if you want to know more about some of our works and how we do at Microsoft AI for Good Labs, we have actually two projects that came recently from our colleague and manager, Rahul, and also the AI for Good book that summarizes all the different projects that are being undertaken in the lab. Any one of you interested, please, you can approach me or Gilles. We can arrange to distribute some of the books. And those who asked a few questions and show more participatory in this talk, I may also reward you with these books. What I'm going to do next is just dive into one of the projects, because I showed you the overview of different projects we are doing, how we do them, then how do we define the problem. But let's dive into one of them. It's not the fanciest problem at all. The methodology is not really complex, but in the process, I learned a few things, and I just want to share with them today so that when you work with domain experts and problems, what kind of things may come up to you. The problem came as understanding malnutrition in Kenya. Again, we have collaborators on the ground. That are Amref Health Africa, which is one of, if not the largest healthcare non-profit in Africa, Ministry of Health in Kenya, and University of Southern California. This is just, the problem could be local, the solution is often, global, right? So the problem appear as such, understanding malnutrition. If we go to the next slide, Aisha, what's even malnutrition? What's even for children? I'm not a healthcare professional, but this is actually a critical problem than I thought. Especially if you think climate change, if you think drought, If you think conflict happening here and there, they actually exacerbate the challenge we have at the moment. And it's worse for children of under 5 because at this time, if children are affected by malnutrition, their future development is adversely impacted by it. And it is the leading cause of morbidity and mortality in Africa, especially in sub-Saharan, for children, including Kenya. So, of course, this is the type of problem you want to work as an African, as a technologist, because you know some techniques, but there is a real problem and children are affected by it and will be even affected more given how things are getting complicated. So our objective is then, let's try to forecast this acute malnutrition in Kenya using machine learning and different data sources available there. That's our objective. Where do we start? Identifying the problem. The problem is trying to identify malnutrition. Probably we have different data sources available. How do we utilize them so that we could infer better about the future? Then, once we have this clarity, what are the resources we have, right? You understand the problem is critical, you get it, okay, let's forecast it in the future. What resource do we have? That's also another key question to ask, because not everyone has a GPU, not everyone has a very big data, not everyone has AI researcher in the team if you consider different organizations as collaborators. So with discussion, we identified that the resources from data is the survey the Ministry of Health has been collected for more than 10 years under the DHIS2, which is District Health Information Software. So it's a survey collected at health facility level. What kind of personal resource do we have? We identified that we have experts, if we go back, Aisha, we have experts at the Ministry of Health who has been working on this problem for many years. We have nutrition experts and policy makers at AMREF Health Africa. We constitute the technical component of developing machine learning models, which is the easiest part compared to the other knowledge the domain experts could provide. And of course, for storage and compute, Microsoft AI for Good provide cloud services. So we define the problem, we have the collaborators, we have the resources now. If you go to the next slide, end user. Who is the end user? The fact that the Ministry of Health is your collaborator doesn't mean that the minister is the one who's going to use it, no. In AI solution development, I do believe it's very critical to early identify who is actually going to use your solution. Is it the community health worker? Is it the county governor? Is it someone at the policy maker at the Ministry of Health? Because you have one problem, you identify the solution, who is going to use it is also very critical. Having that in mind makes you more informed how you can design your solution. I know in research, in academia, usually we focus more on developing the model without even considering who is going to use it at the end of the day. That's why probably we most of the time end up on just complex deep learning model for our solution development, right? So it's very clear for us. The end users are program officers at those ministries because they are the one who are designing interventions in the future. I talk to them and ask, how do you design interventions for children malnutrition in Kenya? Their answer was very clear. We just think what happened last year, the year before, that domain knowledge, and we try to just prepare according to that. But they have been collecting data for many years, but the data-driven decision-making was not very practical for them. Remember, these policymakers at this time, they are not even using window averaging for that matter. So if you are trying to develop a solution for someone who has never used the data they have, even not the average malnutrition prevalence over the last 3-4 years, what kind of solution can you come up with them so that they are also the part of the solution development? I ask that because we always say, look, my deep learning model, it just did great 95 precision recall. No. Having that end user helps you to come up with that solution which must be just enough from where they are coming from. And this conversation always helps us to be, together in that decision making. At the end of the day, you shouldn't, of course, use AI solution because we have data, we have model, we have Azure, and everything. No. What is the impact? The impact, in our understanding, was it is efficient intervention and resource utilization. Efficient means in advance, you know whether southern Kenya or northern Kenya or which area will have acute malnutrition greater than your threshold. Then, once you are better informed about the future, you can utilize your resource accordingly. 2, resource utilization. Practically speaking, I came across in many problems in Africa, there are so many players. If you say agriculture, I could count 10, 11 governmental, non-profit, different organizations working, each on their own. Having such more generic platform would bring these different partners together and also facilitate resource sharing and so on. And ideally, at the end of the day, we may save lives. So I haven't talked about the technical bit of it, but in the process of this problem, once it came from our partners, the problem, the resource, the end user, and the potential impact was trying to be clear. Then, if I show you the snapshot of the data, it has been collected at health facility level. In Kenya, roughly speaking, there are about 17,000 health facilities. And what you see in color are where these health facilities are. So it's not household data, but it's more like people coming to different health facilities and the data was collected from there. Next. And this is the kind of data you have. This is like the clinical features at each health facility under different administrative units. You have often obsolete numbers, and that's like you see empty space everywhere in this Excel spreadsheet. What does it mean? Is it 0 or is it missing? It's not very clear. But this is the kind of practical data we get from our collaborators. And of course, when you talk to the domain experts, even if the data looks messy, try to understand what does this clinical indicator mean, what is the definition, which is very helpful for those of us who are not domain experts to understand it better. What I found it interesting is the outcome. Remember, we are trying to forecast acute malnutrition in the future. So we want to have the knowledge of it in the past. And this is, of course, the type of data. And they have different outcome types, red, yellow, green, or normal, moderate, or severe malnutrition. And what you see, I don't know if it is clear on the screen, most of the time empty, but you see absolute numbers. Which means, technically speaking, at health facility, 5 children were diagnosed with severe malnutrition or they were normal. So this is the kind of information you have. If you try to visualize it, normal means a kid came in diagnosed using the the standard WHO standard, and you say whether it's normal, moderate, and severe. Moderate and severe combined, they are called acute malnutrition. So I have a question for you. We are talking about Kenya, and we are trying to do forecasting. I just saw a Kenyan coming in. At what level should we forecast? At country level? At sub-county level? At sub-county level? At ward level? Or for each health facility? Aisha, if you go next slide. But anyone could comment on this? So far, we came together about the problem, the data, our partner, whatsoever. We said forecasting. At what are we forecasting for the country? Are we forecasting for the sub-county, county? I just want to show you some numbers if you just go. So ward is the lowest administrative unit probably in Kenya, and you have sub-county, county, and you have Kenya as a whole. If you go back, where should we do the forecasting for? For the country? Anyone? Huh? Very low resolution at the lower level. That means we have close to 17,000 health facility. Let's forecast for each health facility, ideally speaking. Any other alternative for? Perfect. At the county level, counter argument. Okay. He's trying to make you use the microphone. So, please explain. Yeah.
Okay, so I think my disclaimer is that I'm a dreamer. I like to think big and then bring it back to reality.
Yeah.
So ideally, it would be good to be able to forecast on all of those levels and see which insights you can draw from those different levels. But I know that reality isn't, it makes it harder.
Perfect. I want to hear his opinion. If you could pass him the mic. Yeah. Yes.
Thank you. Yeah, so the reason why I said county level was because of where the program managers would be implementing. And it's easier for them to see 47 counties and, a high level. Also looking at the data, DHIS2, sometimes it's aggregated level. Health facility, we want to look at, line listing, individuals. So considering the data sets and all of that, I think county level is probably best. Yeah.
Perfect. Great argument. Any other who wants to add up on those two perspectives? All right.
I think it depends on the data. Like, if we have a lot of distribution shift across facilities, so ideally we would want to do it at the facility level, but also like if we don't have enough data points at each facility, then it doesn't make a lot of sense to train a model. So I think it really depends on having an overview of what's happening, like how much data point we have in each place, and then like deciding what to do next. Another solution could be like to develop a model like at the global level and then like fine tune it. Like there isn't like one answer to this. I feel like we need like more information.
That's why we have the discussion now. Any other? Perfect.
I think it'll depend on at
what level you can actually create an impact on. So for example, if your stakeholders can only operate at a sub-county level, then that should be the level of aggregation that you can do. Whereas if you were to kind of predict it at a health facility level, but they can only operate at sub-county level, then there'll be a bit of a mismatch in terms of the findings you give and what they can actually do to tackle the malnutrition.
Perfect, and good to see you. I mean, all those perspectives are great, and there is no right answer or wrong answer for that matter. But I would think similar to what you just said. If you have data, you could just infer at health facility level, and you can build your way up. But that is, as she mentioned, exactly how many data points you have in health facility and so on. And one critical aspect I want us always to also remember is, of course, the data, the auto-distribution is the technical argument, but what does those domain experts, the policymakers we are trying to help actually want? That should be like the most governing question to make a decision. Of course, you could always counteract depending on the data as a challenge, but the first question is usually at which administrative level are you making an intervention policy? Their answer was clear, at sub-county level. And right, wrong, I don't know. But what I know is we have enough data, at least at sub-county level, to infer for that. And again, remember, our task is to make those policymakers better informed. And because of that, we decided to do the inference at sub-county level. But of course, technically, you could also be flexible and do the inference at any level. But this is one way of why you need to engage the end user in the process. So for now, we are aggregating data at the sub-county level and we are making inference. But if we could visualize the data, this is an example of having outcomes of acute malnutrition at sub-county level. This is for county, but you see that it's changing over time. But what we found out is there is no, survey data, if you worked on, it's not really perfect. You don't see that cyclic, clean sinusoidal type signal. It's collected. Some data could be missing. Some people may not even collect the data as they should. If you consider the whole country across 320 sub-counties, there is all that different divergence across the sub-counties, right? And this is like the reality of the data. This is a kind of signal you train your model on to predict the future. And this visualization just makes it how tricky that challenge would be, because we could see how the signal is not really, that informative. And we have also smaller temporal dimension. I think we have the data for 5 years collected monthly, which is like 60. So at sub-county, you have 60 dimensional just vector to train whatever model you have. And that limitation in data is also something you need to consider when you pick a model, because for one sub-county, you have 60 times 10. Even for training, much lower than that, because you train test split. If you go to next, Aisha. So outcome types. So a child comes to a health facility, diagnosed with a health care professional, and you may have normal, moderate, or severe malnutrition. And both of them are acute malnutrition. I can ask the same question. For which outcome should we forecast for? I see a hand. Gentleman at the back.
Answer your question and at the same time do a follow-up question. Yeah, for this, we need the input of domain experts to know how to actually classify the moderate and the severe to be acute malnutrition or not. But the follow-up question is this. You said something about data-driven solution. And also we have this knowledge-driven solution. In AI for good, because in explainable AI, it is key that you put these two into consideration, the data-driven and the knowledge-driven. So in AI for good, for example, if someone is just interested in the data-driven solution and the domain expert is not put into consideration, I believe it may affect a situation whereby you may not be able to make an informed decision at the end of the day. And making an informed decision is critical based on what you said before, that instead of asking those domain experts every year to now say, okay, we are taking decision based on what happened last year, what happened last 2 years, the survey they are carried out. So now you want a situation whereby they should be able to predict what will happen next year or next 2 years and things like that. So that is my response. Thank you.
I agree with your answer. When you mention about moderate server, again, goes to the domain experts, especially for the intervention one. And I think your question actually links back to the solution you gave. In a way, of course, you always need to involve the domain knowledge into pipeline, right? But it doesn't mean that always what the domain experts think is the right way to do. That's why you have the conversation. If they ask, do the inference at health facility level, it is easy. The data point we have doesn't allow us to happen, right? That always happen. But just for the sake of time, the conversation is like always, SEVA is the catastrophic stage of acute malnutrition. In fact, what they told us, actually it's better to mitigate moderate malnutrition cases from not, going into severe malnutrition. So their focus first was moderate. Because of the resource they have, if it is severe, of course it's very smaller percentage, but their aim was actually moderate first. Because if they know in eastern Kenya there is going to be moderate, and if they put that resource, they could mitigate that from exceeding into more severe. But from the design perspective, of course you could always train your model to moderate for severe, combine the two in acute. Since severe malnutrition is very rare, actually it's almost similar if you have moderate and severe alone versus acute malnutrition together. If I go to the next slide, Aisha. How do we model? So is it a regression? Is it a classification challenge? So far, you know what is the data for, where it's collected, at what level we are doing forecasting. And usually, of course, you have the data in raw collected as absolute number, which says 5 kids at this month in this health facility were diagnosed as moderate malnutrition, whereas 7 kids were found to be normal. That is the data. And without thinking, of course, what you do is like you have absolute numbers in your training, and you try to predict absolute numbers. But what's the problem with this? And remember, we are forecasting at sub-county level. Do you agree with this approach, or do you see a limitation of forecasting absolute numbers of children for acute malnutrition at health facility, at sub-county level? You don't see any limitation? Especially sub-counties have different population, different size, different prevalence. If you see the scale, it's very divergent, which means 2 kids diagnosed with severe malnutrition may have different meaning depending where the location is, because sub-counties have different population size and severity. So 2 versus 2 is not really a good indicator of the severity of the problem, because sometimes you have a big sub-county and then you expect higher number of as malnutrition. If the sub-count is smaller, even if it is small number compared to the proportion, it could be a very red flag. So this is like one challenge. You could always throw ULS, TEM, or regression models and predict the absolute numbers, but it has its limitation when you talk to the people. And this motivates us into the next formulation. We are not using absolute numbers because, as we said, it has a different divergence of scale, so that for the domain experts, they should know. You should give more clear information rather than 100 children will have this problem in the next 6 months in Turkana versus in the West Kenya, which has a different meaning, even if the number is the same. If you go to the next slide, again, divergent scale, what we found is the rate. Next, Aisha. So, since absolute number is not, generic in a way, we try to convert that into rate. So now we are not saying 5 kids, 7 kids. Among the kids that came to that health facility or that sub-county, how many of them are affected by this adverse outcome? That means 10% is the same in Nairobi versus 10% in the east, 10% in the south, because you are having that outcome. Have we done anything complicated? No. But we are just trying to formulate the problem in the right way so that it makes sense for the domain expert. And when you project the rate, you could see again that temporal signal, which is not very informative, but at least you could combine the three of them as your common denominator and compute the rate. So from absolute number, now we came to the rate. Next, Aisha. And that tricky signal you saw is not very informative, and it has a very smaller dimension. So that makes it less fitting to typical regression problem. So we try to say, okay, let's change this into classification. Because the way the signal deviates, the error means also different thing, right? And when we try to change into classification, we try to plot the histogram of the outcome across different sub-counties and months observed. And you could see that it's a very skewed representation. So even if we came to now from regression to classification, there are weights another problem. Because across the different outcome threshold, you see the most of the majority is like closer to 0, which means if you have just a dummy classifier that says 0 all the time, you are 80%, 90% accurate. But practically speaking, you are not doing anything really. Because what you want to predict more accurately is the outcomes when they are greater than 0 or so. All right. So I know time is running up. If you go to the next slide, then we say, since the representation is skewed, let's put threshold-based classification. Because if we just quantile the previous one with skewed representation, you will have different number of samples across different windows, and that will be very tricky. But given a threshold, we thought, what is that threshold sensitivity for the domain expert? And that threshold transform our regression into simple binarization to do the classification. And you could see that the smaller threshold you have, the distribution is like less skewed, which is more appropriate to classify. Then, after all this try and error discussion with the domain experts, what we ended up with actually going back into how people in the food security domain interact food insecurity, just beyond malnutrition. And we found that actually there is a standard that's called Integrated Food Security Phase Classification, that actually quantifies the severity of food insecurity in one region. That means you have, I don't know if you see on the figure, depending on the range, you could say, this is IPC scale 5, IPC scale 2, IPC scale 3. That is very common not only for the nutritionist, for WFP, for any other organization working in food security. And finally, we mapped our problem, remember where we start, from those absolute numbers into this 5-point based, technically speaking, 5-class classification problem. And Aisha, if you go to the next slide, even if we don't spend time, how long do we need to forecast again? We discussed at the sub-county level, do you want to forecast the next month, the next quarter, the next 6 months, the next year? Technically speaking, it's just setting the parameter in the code, but practically speaking means talking to again the domain experts. And these are the forecasting timeline they came up. So far, we discussed how we understand the data and the problem from the domain experts. What you could do always as AI researcher is, I got the problem, I got your data, what other data source can I use to complement where I already have? That should be always open for researchers like us, because there's a lot of data that may be complementary going forward. If you go to the next slide, Aisha. So this is the malnutrition prevalence in Kenya, and if you click next, what you see is simple gross primary productivity. You could just easily find from Modi satellite out there. The previous data was collected by the government, lot of money, lot of effort over 10 years. This is the kind of data out there, which is actually very informative if you compare these two maps. The more greener in the West Kenya means there is more agriculture productivity activity on the ground, which relates with, if you compare it with the acute malnutrition rate, less prevalence, right? So this signal, they are inversely proportional, of course, but as a researcher, you can always think about what other data source could I use to complement where I already have. If you click next. So I will not go much into detail. Finally, this is overview of the whole pipeline. Just next. And yeah, at the end of the day, it will be more exhaustive experimentation, comparison of very simpler methods and different data sources, but this is not the most interesting part. And of course, deliverables, we have the dashboard we are trying to develop so that the domain experts we discussed earlier could just easily see what's happening in Kenya for this problem in 3 months, 6 months time in the future. Of course, you need to make sure what we did, scientifically makes sound, and of course the paper is under review. So, as I said, that was not a very complex problem model, but the process we follow from the domain expert into the solution probably share some things for you to consider going forward. So I know time is running up. As someone who has been lucky enough to work with great colleagues and in AI space, at least for the last 5-6 years on these interesting problems, what are the things I wanted to share with you? One, prioritization is key, as you often say. There is a lot of problem, definitely, but which one to spend your time, money, resource is very critical. And that's something I want you to consider. Two, by now it's very clear. At AI for Good, including many, I would appreciate, no one can do it alone. Every problem is very complex. And for that, you need a lot of collaboration. That's why in our lab, we see a lot of collaboration for each project, and definitely that's something you should also consider if you are working on AI for similar problems. Next. Again. Problem. The clarity in defining the problem is very important. As someone said, an appropriate answer to the right problem is much better than a perfect solution for an approximate problem. And usually, we researchers, since we are not domain experts, we oversimplify problems. We assume we understand the problem, but it's actually very tricky. I just came back from Ishkai conference in Korea, and I was chairing a AI for Good track with Georgina over there. And I asked someone working on, I think, disadvantaged population in the US. I asked her, what do you mean by disadvantaged population? Her answer was, a bright student, actually it's a common sense. There is no common sense in problem. We need to go deeper and clearly understand and define exactly what we mean by that. Not just because we have the latest paper or some data set on a particular problem, we just understand the problem. No, problems are quite complex on the ground. Next. Deliverables, of course. When you work on partners, collaborators, you need to make sure that what are you going to deliver at the end of the day? Is it a report? Is it a dashboard? Is it the code? The more you inform yourself earlier is the better, because the policymaker is expecting a report from you, but you bring a GitHub repo for him. No, that understanding is key from our experience. Next. Clarity on impact, resource, and end user. We already discussed that and tried to showcase in one of the projects I discussed, so I will not spend more time there. Next. Of course. Local context really matter. I just finished the book from Wangari Maathai, great, environmentalist from Kenya, as you know. In any development organization, seaside, you think you are doing the right thing, but in local context, you may be off track, really. And this is for even environmental. And if you think about AI, it's even more important, because usually we use data from somewhere, model from somewhere, where we try to work on African problem. Next. Surprise, of course. When you work with people, domain experts coming from different perspective, be ready for surprises. There was a time I just went into a room with a domain expert, and I was asked to lead a prayer for that meeting. You don't expect, right, to go. You have your PowerPoint to talk about AI, but you ask to lead a prayer, right? That is how sometimes you work with people, you understand people and relationships. Again, food security, healthcare, you have so many players working on that some domain. Of course, you cannot encompass each and every one. Sometimes we try to just pick one and update the rest. Because I'm an African, you know that if you have that conversation every week, you will not go anywhere, because people come from different background, perspective, and you keep, so pick one and update the rest is the way forward if you want to progress. Be the first mover. There is a lot of problem, a lot of challenge. You cannot discuss sometimes just non-stop about the potential solution. This was the case when we had the Kenya flood in May. And the President's office, contacted all the tech sectors in Kenya to understand the flood extent map. And Air for Good Life was the first to just generate that. Once you generate where the flood happens in Kenya, different organizations can use this as a layer to understand more. Some are keen on understanding flood on infrastructure, some flood on wildlife, some flood on migration camps. So sometimes it's just, even if you don't have the perfect solution, be the first mover. This is a challenge we often have. We always think in AI, in technical mindset, and when you talk to doctors or agronomists, you always have that mindset. No. The same thing, the same conversation, but you always need to calibrate how you communicate that. If it is a scientific audience, if it is a decision maker, the policy maker, so you have different ways of projecting and communicating your idea depending on your audience. Of course, we are in Africa. We are proud deep learning in Indaba is unique compared to Ichkai or NeurIPS, because the way we do things is different. And in Africa, definitely, personal relationships matter when you work with different partners. right? And that's just from the experience. What else do we have, Aisha? Keep focused on deliverables. Sometimes you may have conversations going on and going on, but engage partners, engage domain experts in your progress, but it doesn't mean that every week change according to their comment. You always need to have a clear focus on what you are going to deliver at the end of the day. Did we finish? Of course, be patient because sometimes things take time, especially if you involve lawyers, for example. You have a collaborator, great problem, you want to have a data sharing agreement. Lawyers can have that conversation for 2 months, 3 months. And you cannot say hurry up because it's data. But at the same time, you need to be patient because they are also part of the working system. I guess by that, I finished my conversation. Really appreciate your time. Any quick question? I know we are out of time, but I can take a few questions. Is that right, Aisha? Two questions, okay. Okay.
Thank you for the wonderful presentation. It was really enlightening. My name is Lukman, and I would like to ask about the implementation. So last year I took a course on Coursera, AI for Good by Robert Monarch. So there he explained that a large number of the projects he worked on didn't work through. He explained some of the impact and the reasons. So I want to know, in your own experience, have you been able to deploy so many, and is your own percentage of success better? And if not, the way forward. Thank you.
Can we have other questions so that I could address together? Yeah.
Thank you. My name is David Gishoy from Kenya. I'll refer my question to data. And you've talked about that data is the key part that you are going to start from when trying to get a solution of these problems that we have. Now, being a Kenyan, I know we have a challenge, as you've explained, of having this data being available. You've shown us data that we are not sure whether it is there or it is not collected. How do you deal with that? The other question is, we know one other factor that affects these solutions is political instability. We have politicians who affect this process. Is Microsoft AI for Good Lab able to maneuver through this instability in their work? And the last question is, when you are collecting data, how do you collaborate with the Office of Data Protection, knowing that Kenya has a Data Protection Act 2018? Thank you.
Great question. I hope I always remember them. There are three, I guess. But the first question was about impact deployment. And yes, it's a work in progress. What I try to share today is some of the key components you take into consideration when you try to develop AI for practical, including deployment. And of course, usually we try to work with collaborators. Some of them deploy the solution. Some of them, they just get the insight. But the Kenya flood is a good example, which just last May. And we out there, and a lot of partners have already used that to understand better that impact of disaster. And we are working with the Kenya Space Agency even to have this in their pipeline in the future. For the question about data, that's what I said when I talk about trustworthiness, focus on data. But no data is perfect. The way forward is always understanding the limitation of the data you have and trying to complement it with other data sources you have. Yes, of course, you have to work with the Office of Data Protection. Usually we have workshops, seminars, even in Kenya. But overall, you need to work with according to the law and regulation in each country you work on. And that will be my answer. I know we are out of time. If you have any questions, Jules is here sitting, if you raise your hand. And I will also be around. And Akram, if he's here, just approach us. Happy to talk, to discuss. And yeah, as I said, we have also a few books to share around. Thank you again.
Yeah, thank you so much. I know Girma always open room for discussion, but thanks God he's going to be here for all the weeks, and also you have the chance to talk to him. We have mentorship for G Special on Thursday during the lunch, and we also have a workshop G Special on Saturday. He will be there. He's also going to lead the parent keynotes on Saturday afternoon. So yeah, you have a lot of opportunities to ask him questions. Thank you so much, Girma. Yeah, so now we have the coffee break there. And then the sponsor sessions are starting at 4 p.m. I think you have only 20 minutes. I think it starts by the hackathon. Enjoy the rest of the day and see you tomorrow. Thank you so much.
Hi everyone. We will be starting the hackathon launch in about 3 to 4 minutes. So please take a seat and yeah, we'll be back in 3 minutes. All right. Hi everyone. So we will start with the hackathon launch, starting with the Meta hackathon for about 25 minutes, and then we'll move to the InstaDeep hackathon. If you have questions, we've invited a few of you who showed interest already to Slack channel. If you'd like to join that channel, please let us know. There is also a form that you can fill going out in every day's communication to all attendees so that you can ask questions and be updated like where the mentorship is happening, etc., right? So now let's start with the Meta hackathon, please. Yeah. Fargani.
Thank you, Yassine. Good afternoon, everyone. I still hear a lot of chatter in the room. Good afternoon, everyone. Great. My name is Fargani Tambayuk. I am the Director of Public Policy for Francophone Africa, but I also lead our connectivity and innovation policy work across all of SSA. And it's a real pleasure and privilege to be in front of you today to launch this hackathon. So I'm here with colleagues, and they'll take the stage after I'm done with the few words I have for you to provide you more details on the hackathon. But let me start by describing a scenario. Imagine you're in Accra and you're excited about coming to this deep learning in Indaba. You're coming to Dakar. You're trying to book your hotels, transportation from the airport, and you're trying to plan activities, connect with people in the city. But there's one challenge. You only speak Twi, and people in Dakar only speak Wolof. How would you enjoy this Indaba? How would you form those connections and really benefit from all the insightful things that are being shared in this Indaba around AI? Think of another scenario. You're an entrepreneur in Tanzania. You're trying to expand your business online. You only speak Swahili. You've been contacted by clients or potential clients or customers from Brazil, from Portugal. They only speak Portuguese. How would you communicate and seal those deals and really take advantage of those commercial opportunities. And that is where AI, open source AI, particularly around low resource languages, plays a very important role. Because by leveraging such solutions, you can break those communication challenges or gaps and really harness the opportunities, connect with communities across the world, grow your business, discover new places, because you've been able to leverage open source large language models to develop tools that empower such effective communication. And that is what this hackathon is all about. Are you able to use a Meta large language model to translate English to Twi? The scenarios that I've described are real scenarios. These are real challenges that young people, innovators in Africa face day to day. And the solutions are also being developed every day on the continent due to the power of open source large language models, which is something that Meta is really passionate and committed about. We want to open source AI so that African innovators, entrepreneurs can build solutions to their local contexts. And this is not just a dream, it's a reality today. We already have 350 million downloads of the Llama models since they were launched in February 2023. What does that tell you? That tells you that there's a large community of innovators in Africa and across the world that are leveraging these open source models to build solutions for their local communities. I think we even have one of those innovators in the room, Jacaranda Health, Stanislas. They've leveraged tools like Llama to build other open source language models in 5 languages, right? 5 languages across the continent. So these are things that are already happening. And when you participate in this hackathon today, don't think that you just participating in a hackathon. You're actually building AI solutions for Africa. You're shaping the direction of AI for Africa. On that note, I'll hand over to Delilah to give you more details on the hackathon. Thank you.
Hi, everyone. My name is Rose Delilah Gesicho, and I'm here representing Zindi as a community manager. And I just want to know by the show of hands, how many of us have used Zindi before? Oh, awesome. So I'm just going to be taking you through this amazing competition that we have by Meta, where we'll be tuning Meta LLMs for African language machine translation. First of all, I would like to shout out Ghana NLP for providing this data set, which we'll be using to translate English to Twi. And I love that we're able to build this community together, and this contribution that has been made by an amazing community, the Ghana NLP. So to the Ghana NLP team, thank you. Next slide. Yes, so on to the competition, as it has been mentioned by our amazing Meta individual here, that will be doing machine translation model from English to Twi. I hope it said Twi, yeah, which is a Ghana language. And by enabling this, by enabling the accuracy of this model, or by enabling the accuracy of this LLM, it will enable us to develop solutions that will enhance access to digital content and services for Twi speakers, as it was mentioned during the presentation. And for the data set that we have 4,800 sentences in our trained data set and 3,200 sentences in our test data set. And for the winning solutions, this is a really important part that you need to take note of, because if you're taking part in the essence of maybe getting a solution and also winning one of our prizes, this is a very fundamental thing to take note of, that the solutions must must use open source models from the meta repository on Hugging Face, which includes NLLB, 200, Seamless, M4T, Llama, and any of the derivatives that come from these models. So I hope you have taken note of this if you want to learn and also just compete in this competition. So this is a very important thing also to note, and we really recommend you to join in as teams, because we'll be prioritizing people who join in as teams to give them access to Google Colab's virtual machines. So the virtual machines will have this, it will have 8 CPUs, 4 cores and 32 GB RAM, 1 NVIDIA L4 GPU and 200 GB SSD disk. So we'll be awarding this to the first 100 teams that join. So we are prioritizing teams. And if you want to know how to join a team on Zindi, you can just scroll on the description of the competition and you can be able to see how to join a team. And the solutions must train and have just have the inference within less than or equal to 8 hours. So when you're training your models, just ensure they're within 8 hours. I know it might not even reach that, but that is it cannot exceed that for the resources that we'll be giving you for the people who will be participating and be awarded these resources. And then on the discussion, once you join, I will give you a secret code at the end of this. Once you join, please go to the discussion on that competition, and you'll submit to us your Gmail account so that we can be able to send you all this information. And also on the same page, we have a detailed walkthrough of how you can use these virtual machines. So please ensure that you join the competition for this information. Yes, and now for the exciting part that I know most of us have been waiting for. The winners will be getting this awards. So the first winner will be getting 2,500 USD. The second winner, 1,500 USD, and the third winner, 1,000 USD. I know this is life-changing amounts for most of us who are students. So yes, please have a look in this competition and you'll enjoy it. And again, the prizes will only be awarded to those who register for with the deep learning Indaba secret code that I'll give you. So if you share it to someone maybe who's at home, we'll be able to detect and yeah, you might be disqualified from the competition. So just take note of this. And again, the winning prizes must be, you must use open source models from the meta repository. Take note of that. Yes, so this is the timeline for the competition. So we'll be launching the competition. Today, but for you to form the teams, you need to form them, and the deadline would be Tuesday, 1 p.m. to forming these teams. So that's the deadline for team creation. I hope you've noted tomorrow, 1 p.m. And then on Tuesday, 4 p.m., we will be now sending out the emails with your specific VM or virtual machine information. So once you have signed in as a team, we'll be able to now send out the virtual machines to you guys, and you can compete with them. So the deadline would be by 4 p.m. tomorrow. And then on Friday, we will close the competition because we need to announce the winners at the end of the DLI. So at 2 p.m., the challenge closes. And on the Friday of 6 p.m., the top 10 on the private leaderboard will, okay, actually 30 minutes after the competition closes, we will have the top 10 on the private leaderboard emailed to send in their codes so that we can review them. And then during Saturday at 2 p.m., we will have the reveal of the private leaderboard, and also we'll have the award session for DLI here. So I hope you've taken note of this. They're also on the Zindi page so that you can be able to look into them. I think the most important ones are for you to check the deadline for team creation, and also check the email that will be sent to you for the VM machines that will be provided. And then once the challenge closes, ensure that you check your emails to see if you received an email to send in your code for review. Again, we won't tell you who's number 1, 2, 3. We'll just say these are the top 10. You are one of the top 10 teams or individuals to be nominated, and we give you that information, and then we'll reveal, the winners on Saturday. Yes, so without further ado, this is the secret code. So just scan this QR code, and then you can put in this on the join the challenge, and then you'll be ready to go. We'll have the data released. Yeah, it's already released. So just get ready to join teams, collaborate, and I'm looking forward to seeing the amazing solutions that come from this. Thank you. Maybe I can note one last thing. We also have representatives from Deloitte. Maybe I can see. Okay, great. We have representatives from Deloitte who will be doing a workshop on Llama. So he will come in and share more about that. And it's very vital because we are working with Meta repositories. So if you are really keen on taking part in this competition and you want to be the best of the best, I think this is a workshop you should watch out for.
Thank you. You already did all the preview and marketing for me. But you're probably now wondering, where do I start? How do I go about this? What's the steps that I need to take to actually have a good solution at the end of the hackathon? And tomorrow at 4 o'clock during the practical sessions, that's what we'll do, right? We'll take you through a very practical tutorial in terms of how do I actually go about, where do I start, what do I do, how do I actually tune and train this model? That's the first one. The second one is, okay, I can translate from English to Twi, but so what, right? What are the use cases that would be useful for? So I'm Quentin Williams. I'm from Deloitte Consulting, and when people hear Deloitte, they think audit, but I'm Deloitte Consulting. I actually lead our AI business, which means I help organizations understand how to use AI to create value. So that's the second part of our workshop, is actually understanding use cases that large corporates are using large language models for, so that you can see, yes, I can do a translation and I might win this competition on Friday, but what do I now go and do about it? How do I actually go and create a solution around it? And then once you have a solution, create a product around it that actually makes commercial sense. And I'm hoping that you guys will come to the session. Me and Simone will be there to actually show you guys really and to talk you through how do I actually, go and win this hackathon. We won't give you all the answers, but hopefully we'll get you halfway there. And then I will also be available for mentor sessions from 1 to 2. For those of you who don't know me, I did my PhD a long time ago in AI, spent 14 years at a research institution in South Africa, and the last 6 years at Deloitte. So if you're ever thinking about how do I combine academia and research with corporate, or want some information around either one, I'm happy to chat, and I'll be from 1 to 2. The information around where those mentor sessions will happen will be shared tomorrow morning. So please keep yourself open. I'll be there and happy to chat about those things. I think I'm handing over to Instadeep now, right?
I'm just waiting for the Instadeep presentation to appear on the screen. Okay, welcome everybody to the hackathon, and the second hackathon will be about snake venom. So when we were thinking about a topic for this hackathon, we thought we want to pick something that's like relevant for this community. And if you can go to the next slide, please. So in Africa, there are a lot of people who suffer from snake bite, and for this reason, we selected a data set which contains snake venom from about 20 snake species, several of which are present here in Senegal. Next slide, please. Next slide. So this hackathon is a collaboration between InstaDeep and the Technical University of Denmark. InstaDeep, hopefully a name that's familiar for most of the people here in the audience. We do a lot of great work. If you want to know more, visit us at our booth. Next slide, please. And this was a research project in collaboration with Digital Biotechnology Lab, a team at the University of Denmark who have a lot of expertise in proteomics. Next slide, please. So, why snakes and why snake venom? So, if someone is bitten by a snake, it has like a devastating impact on the community. People have like lifelong disabilities. They can no longer work. They can no longer provide for their family. In some cases, there are even fatalities. So it's an important problem, but it's one that's not well tackled by like the big pharma companies because there's there's not much to earn from it. So it's like one of those problems that is underfunded. And that's why we think the people here in the room can make like a difference on these kinds of topics. Next slide, please. So I wanted to highlight some of the snakes that appear in our data set, which are very lethal and which appear in our data set. The first one is the green mamba. It's a rather shy snake, so attacks don't happen very often, but once it does attack, for example, because you step on it, the venom acts very quickly. And in about 30 minutes, if you don't like immediately treat it, it becomes lethal. The puff adder, on the other hand, is a very aggressive snake and is known to like attack without with little warning. And because it is so aggressive, it is also the cause of a lot of snake bite fatalities in Africa. The spitting cobra, as the name it says, is famous because it can spit out the venom, and if it hits you in the eye, you can get blind, which of course has a big impact if you want to do your work. And then latest one, the carpet viper, has a venom that's like extremely toxic. So all these snakes appear here in Senegal, and what we're trying to do is develop a solution to find like the exact proteins within the snake venom, because once we know those proteins, we can start to develop antivenoms. Next slide, please. So here is an image with like the three-dimensional structure of those proteins within the snake venom. So we want to say someone is bitten by a snake, but the snake has disappeared. So we want to like very quickly know what was like the snake that the person has been bitten by. Is it like a dangerous venomous snake or not? So one way we can do that is by using mass spectrometry to analyze the sample and to find like the exact peptides that are in the sample. We have just had like an hour-long talk given by my colleague Niklas about mass spectrometry, so I'll go rather quickly through the slides here. But if you're interested in, we can give you a lot more information. So mass spectrometry exploits the fact that all the basic atoms have different weights. For example, the first one you see there, carbon has 6 neutrons and 6 protons, and each neutron is about each neutron is 1 dalton. So a carbon has a weight of 12 daltons. You can have isotopes, which are like different variants of elements. For example, carbon 13 has like an extra neutron. That's why we call it carbon 13, which means it has a weight of 13 daltons. So with all those building blocks, you can start to build the amino acids. Next slide, please. So here you see the list of 20 amino acids, and each of those amino acids have a specific molecular weight. The first amino acid you see over there has the weight of 165 daltons. So if we start to chain those amino acids together, we start to build a protein. Next slide, please. So now, for example, we added alanine, second amino acid. You see the molecular weight increase to 236 daltons. And next slide, please. If we go further and further, we can build our peptide. If you go to the next slide, please. Here we see the whole peptide, and the total molecular weight is 1,973 daltons. So this is, if you know the sequence, you can exactly calculate the molecular weight, because we know the weights of all the individual elements. What happens in mass spectrometry is the reverse. So we can find, using mass spectrometry, the weights. If we want to calculate back and find the peptide sequence of the peptides in our sample. Next slide, please. Next slide. But peptides are like very small. You can't like put a peptide on a scale and weight it, measure its molecular weight. So the way mass spectrometer weighs is they ionize the particles, and by that process they can measure the charge, and that's the way they can deduce the molecular weight of the peptides. Next slide, please. We skip over this. Next slide. So this is the whole process of mass spectrometry. Nicholas just gave like a detailed presentation, but in short is we have the sample, we ionize it, we select, so the sample contains multiple peptides, so we select one that we want to study. It's fragmented, so blasted into pieces, and then traditionally, before deep learning, the way you go from the spectra to the sequence is you do a database lookup. So you try to see the spectrum I have, does it resemble anything in a database of an existing spectra? That works well if the species or the organism you're studying is well studied, but it fails if the species you study is like rare, or in the case of snake venom, where the peptides are not well studied. So with the advance of deep learning, we, instead of this database-driven approach, we are now starting to go to what's called a de novo approach. So we don't need a database anymore, but we train a model on a large number of spectra labeled with the peptides, and the model learns the grammar or the structure of the spectra, and that model can now make predictions. So you give it a mass spectrometry spectra, and it predicts the peptide sequence. Next slide, please. So that's again what I just told, visualized in another way. So here you see we have the traditional method, the database search, and what we're going to do with deep learning, the de novo approach. Next slide, please. So the model I talked about was developed as a collaboration between the team of InstaDeep and the team at Technical University in Denmark, and it's called InstaNovo. It's a transformer model. The input is the spectrum and the precursor mass and charge, and it predicts peptide sequence. If you want to learn more about it, we have a preprint published. So if you want to gain an edge during the hackathon, read the preprint and try to understand how it works. That might help you in yeah, getting a good solution. Next slide, please. We skip over this. Next slide, please. And so we have some terminology. It's explained in the notebook, so we skip over this. Next slide, please. So how does the data look like? So on the Cindy platform, you will download the data. It's a CSV file, and it has several rows. So you have a unique experiment ID. So the experiment IDs correspond to the snake species. So that's something that you can use if you want to do something like normalization, for example. So normalization per species. We have also a global ID, and then we have the mass and charge of the precursor mass, and we have the two arrays, one with the mass over charge values and one with the intensities. So previously I showed like the graphs of the spectra. On the x-axis you have the mass of charge values, and on the y-axis you have the intensities. So that are the last two columns with the arrays of values. Next slide, please. So with those values, you can create the spectra. Next slide, please. The model we developed, the InstaNovo model, it does a beam search. So there are several beams that predict a peptide sequence with different probabilities. But it's not guaranteed that the beam with the highest probability is the correct predicted peptide sequence. And that's where the challenge comes in, or the challenge here. So real-world data is noisy. So we can improve the predictions that our model makes by rescoring the predictions. So we're not going to ask you to train like a model, because training this kind of model took us several weeks on big A100 GPUs. So that's not feasible for a hackathon in 2 days. So with the data that we provided you, it all runs in a Colab notebook in, say, less than 5 minutes. I'll show you shortly. We have provided a notebook with step-by-step how to download the data and process the data. In the notebook are also several hints of things you can try to improve the metric, that you need to improve the area under the curve. So if you're like a beginner and yeah, are interested in the topic, and you don't have like access to big resources, or you want to be able to run it locally, I think this is like a good hackathon topic. Next slide, please. So what is the metric that you're trying to improve? So the metric we're trying to improve is the area under the curve. So the blue curve is the original curve, and in the sample notebook we give like a basic example of how you can filter the predictions to slightly already improve the curve. So the orange curve is the new predicted curve, and we want the orange curve to be as much as possible in the top right corner. So the more in the top right corner it is, the higher the area under the curve, the better your AEC. So there are two ways you can do that. So either try to get the orange curve more to the right. That means making more correct predictions. So the 5 beams that we give have all like predicted peptide sequences, but it's not guaranteed that the correct predicted peptide sequence is one of those five. So if you can find like a way of generating better predictions, that gives you a way to pushing your curve to the right. So read our preprint. We have a diffusion approach. So see if you can get some inspiration there to push that curve to the right, and also more to the top right corner. Next slide, please. So that's how your submission file should look like. So you have the unique IDs, the target, that's the predicted sequence. You will see some of the sequences have like numbers in brackets that are that's called post-translation explained in the starter notebook. And then the confidence you have for each peptide prediction. Next slide, please. Yeah, so why do we do the rescoring? Because, like I said, the real-world data is noisy. We can have either missing peaks or extra peaks due to noise. So try to understand the reasons why the data is noisy, try to remove this noise, filter the data, and so that way you can like improve your predictions. Next slide, please. So we have a starter notebook where we step by step explain what is de novo peptide sequencing, how can you use mass spectrometry there. We show you quickly how to clean the data. We give some helper functions to plot the data, and we apply the theory of mass spectrometry to calculate the theoretical spectrum. We also give helper functions to calculate the area under the curve and give you some hints on how to improve the curve. Next slide, please. So that's the post-translational modifications you see at the bottom. So a post-translational modification is you have your amino acid, and after the amino acid is formed, for example, an extra oxygen or phosphor element can be added, which is something that happens in nature. Next slide, please. Also, something, a gotcha that you have to be aware of. There are two amino acids, isoleucine and leucine, who happen to have like the exact same mass. So if you see that mass with the data that's provided, it's not possible to make a distinction whether it's isoleucine or leucine. So that's also something that you can put into your model to take that into account. Next slide, please. So here is an example of the top half of the graph shows the theoretical data. The bottom part of the graph shows the theoretical spectrum, and you see some of the peaks match, so that's good. And the peaks that don't match are either like when the peptide is fragmented in other ways that we don't account for, or is noise, or like other artifacts. So you have to remove those peaks. Next slide, please. Here is a graph we provide in the starter notebook where the beam search algorithm, we take the top 5 beams and we give you the probabilities and the predicted peptide sequences, and that's what's shown here. So the beam 0 is the most confident prediction of the model, but it's not necessarily the correct one. Next slide, please. So to join the hackathon, scan this QR code, use the password #Senegal 2024. You're encouraged to form teams of up to 4 people. I know it's a very technical topic, so it helps to if you can sit together with a few people like discuss what's happening and bounce ideas of each other. Only people here present at the Indaba can participate, and you can make up to 50 submissions. You're welcome to use any framework of your choice. The starter notebook uses PyTorch, but feel free to use JAX or anything else. Next slide, please. So the competition closes Friday at 2 p.m. and around that time, check your email. If you receive an email, say 2:30, that means that you're in the top 10, so that you make a chance to win the prize or one of the prizes. So at that point, you will receive an email from Zindi with a form that asks you to fill in a few details and upload a few files. So you need to provide your username, or if you're teaming up with a few people, your team name, all the emails of the participants, whether you use the GPU. We think for this challenge it should not be needed, but if you use one, mention it. The time it takes to run the full solution, we have in the starter notebook added some code that automatically shows that for you. If there are some special instructions that we need to take into account at the README, and then of course the file you submitted to Zindi with your best solution and the full notebook, so that we can reproduce your submission and judge it. So one tip, when you are working and submitting, every time you make a submission to Zindi, take a copy of your notebook with like the public score that you see on the Zindi leaderboard, because we will ask you to submit your winning submission, and if you have, or like all the time changing code in the notebook, it's very hard to find back like the exact configuration and number of parameters you used in the starter notebook. By 6 p.m. On Friday, we will close the competition, and we will start judging, and the final results will be announced at the closing ceremony. Next slide, please. We have a total prize pot of $5,000 US, with half of it going to the team on first place. We also have 2 office hours, so tomorrow and on Wednesday, each time from 1 to 2 p.m. There will be one of the interview rooms where me and my colleagues will be available to answer all your questions, both regarding machine learning or the biological, like mass spectrometry and all those topics. The exact room number will be announced on the Hackathon Slack channel, so make sure you enter the Hackathon Slack channel as well. And the battery is empty, so it's also the end of my presentation. Thank you very much.
All right. Thank you everyone for attending. Now we'll have parallel sessions in study. We'll have Mila in Annex 1, L'Africa Mobile in Annex 2, and NVIDIA in Annex 3. The sessions will start in about 7 minutes, just enough for you to actually choose the session you'd like and dispatch in the parallel sessions. Thank you for attending, Mika.